we are going to do an intro to entertainment networking. So I did this presentation for some folks in New York City last year, and all of our evening events are in the evening. And my running joke with the build up of this was that networking is not all just about martinis and business cards. So this presentation is martini themed. And I hope you like it, and I hope you get to have one. If not now, then maybe later in the day. So what do we want to cover? Really, we want to talk about entertainment control systems, sort of what their tradition is and the intent. Why do we build entertainment control systems? We're going to go over networking 101, discussing topology, terminology, useful protocols, things of that nature. We're then going to do a little lighting protocol showcase. So that's going to go over things that we use specifically in networking that are lighting. Then we're going to look at actually building a network for entertainment control systems. We have some very specific decisions we make that take networking and make it good for entertainment in particular. So what are entertainment control systems for? Why do we build them? Entertainment control systems are purpose-built. We like to get data between devices quickly and efficiently and reliably, right? So we still like to use our own network for this reason. Hopping on other people's networks that have different priorities for how they configure things is not something that we like. We generally still like to stay sequestered from the real world. So something to keep in mind when building something. And we want to make sure that our network is optimized to be real time. So real-time networks have a lot of properties that we need to deal with. As we'll look at, the internet isn't designed for real-time delivery. So we have to do a lot of specific things to make that real time happen. If your email is sent today and it gets there immediately, and then tomorrow it's 2 minutes late, that's not generally a big deal. But if you hit your go button today, and then you hit your go button tomorrow and it's 2 days or 2 hours late, 2 minutes late, then that's going to be a big problem, and you might get fired. So we're going to do a lot of unconventional things to networks to keep them real time. We also want all of our decisions to be risk averse. Again, the lingo that's in IT is what's called a zero downtime network, right? This thing has to run all the time, be consistent, and get the data there always. We can't have it tip over. We do architect things in a way as well that minimizes risks, but also makes them easy to bring back up if something does fail. And then we need things to be scalable. And scalability is a big deal because our rigs are getting bigger and bigger, right? We're adding tons of additional equipment, and our creative teams are expecting more and more from us. So hopping on that immediately, it's all about scale. When we distribute DMX, we can have 512 addresses on a wire. And 10 years ago and before, 512 dimmers was a lot of fixtures, right? We had a lot of flexibility. But now it's just not very difficult to get fixtures that take up a much larger DMX footprint. So even static LED fixtures can take up 10 addresses. So now you're talking only 50 fixtures in a whole DMX universe. If you look at something like a moving light that takes up something like 50 addresses, now you're only talking 10 units per universe. So the scale that we've encountered as more and more things get intelligent has made making our system scale way more important. Just a note here, don't forget that optosplitters don't get you additional output, right? They just duplicate addresses. So if we're sticking optos into our system, that's more of a distribution method than it is actually architecting additional outputs. Here's why we go to networks, right? Networks have a lot more flexibility and distribution down a single wire. Streaming ACN, which is one of the most common lighting protocols, allows for 65,536 universes across a single cable. So that's a little over 33 million addresses. If you're working on that show, I want to come see it. Basically, the networking offers you scalability that DMX really isn't capable of. You'd have to have a huge bundle of cable coming out of your desk in order to distribute this with DMX. So we use, and you'll hear me use this term often throughout today, our network is our big pipeline that gets data just throughout the system. And then we use things like DMX gateways to break that stuff out into universes. We're still using DMX at the end of the system, what we call the last mile or the end of line protocol. And there's some specific reasons for that we'll talk about later on. We're also using universes in a different way now that we're hopping on the network. You know, it used to be that universes with a console were use it or lose it, right? You filled up your universe as much as you could because you never gained those addresses back. And that's not how modern control systems work. We're using universes as organizational tools to be able to sort of spread things out through our system. So while we can have a gateway that does universes 1 through 4, there may be a reason that we have a bunch of different universes coming out of a single gateway. Maybe we're breaking up our system via fixture type, so it's easier to patch. Maybe we're breaking things up by position. We have certain universes at certain locations. You know, universe 101, 102, 103, 104 correspond to my overstage electrics or something. Universes are now much more organizational than they've ever been, and you should consider that when you're laying out your system. So let's go into a quick overview of the basic components. So regardless of kind of specific hardware, I want to take you through some concepts that put a network together. The three basic components of every network are a node, a switch, and what's known as a segment. Nodes are connected through a switch, and the switch is designed to take communication and pass it back and forth between the nodes and facilitate that communication. Notice that the segment has a maximum length of 100 meters, or about 328 feet. Keep in mind that networks are just electrical circuits, right? So there are some constraints around them as to how far we can run them before we start to see degradation in signal. And also notice that a segment consists of not just the wire that's in the wall, but also the patch cables, right? So if you've got, 75 meters in the wall, and then you've got a 100-meter patch cable that's coiled up and sitting next to your gateway, that could cause you problems. And what you'll start to see is a degradation in signal quality and sort of intermittent communication. We'll talk about a little bit of that troubleshooting in a bit, but this is really, really important. Again, networks are just electrical circuits, and the segment length is a really important part of making sure that the data delivery is successful and consistent. Nodes. What is a node? A node is any device that's connected to the network that's capable of receiving or transmitting information and talking to other nodes. So, your laptop or your tower is a node. Your lighting console is a node, and your DMX gateway is a node. Kind of. There's a little vocabulary thing. We've kind of, for a lot of years in entertainment lighting, sort of exchanged freely the word node versus gateway. And that's a bit of a misnomer. In proper networking terms, a node is any end device. So again, your console is a node, your demo rack is a node, your gateway is a node. The word gateway in proper networking denotes a piece of equipment that translates one protocol to another. So my DMX gateway is something that translates ACN into DMX. and actually it does transfer DMX into ACN if it's an input. So we call these things a gateway to differentiate them from all of the other nodes in proper networking. I put down here a response DMX to Dolly gateway. This is an example of a proper gateway, right? It's not on a network, it's not communicating with other devices, it's simply receiving DMX and translating that to a different protocol, which in this case is Dolly. So that's an example of a proper gateway. So, just mean what you say and say what you mean. So copper wiring is how we build up segments. Category cable is inexpensive to deploy, right? It is used in every part of the world now because networks are everywhere. Here the terms E and FTP, those are unshielded twisted pair cables and shielded twisted pair cables. So be aware of those differences. There's a lot of different types, and we have a lot of discussions with people often about which one is proper. So you'll notice that Cat5e, Cat6, and Cat6e, Cat5e and Cat6 are, and Cat6e are all capable of 1 gigabit per second transmission rate. So I think people get worried about not having the latest and greatest networking technology that they're going to be needing to upgrade. And the fact of the matter, Cat5e has been around for over 15 years, and it's still capable of gigabit technology. So what you want to look for really is just the rating of the bandwidth, right? The 1 gigabit per second, the 10 gigabits per second, when you're determining what cable is good for you. A lot of cable manufacturers will use the amount of hertz that can go down the line, how quickly data can transfer down the line as a means of quality. But higher hertz also introduces crosstalk, which is electrical interference between the pairs when they're talking. So overall, with higher crosstalk due to higher hertz and other things, you really just need to be looking at the sum of all of that, which is what the actual rate is. So just keep an eye on that. What else was I going to say about that? Oh, right. So the biggest thing outside of your cable is that the electronics that are connected to your cable are really going to be the ones that determine the speed of your network. Your switches, your nodes, things like that are more likely going to be what's going to allow higher or lower speed. You have to think about the cable as the pipeline, and all of the nodes are valves, right? And they control how much water pressure is going down the line. So for gigabit networks, which are still really, really good for most applications for control networks, your Cat5e all the way up to your Cat6e are completely useful. So there you go. The other thing that's part of the cable is your RJ45 connector. RJ45 connectors were created for the telecommunications industry and really weren't designed for sort of rigors of production, right? Their mate and break cycles, the amount of times they will be effective as you connect them and disconnect them, is 500. And that's like a day on a stage. So these are really patch cables that have RJ45 connectors should really kind of be considered expendable, as they break down, as they sort of fall apart. You need to just be able to dispose of them or re-terminate them. The other thing is that the plastic tab on that cable is designed to keep that cable seated and to keep the electrical contactors engaged with the port that it's plugged into. So if your plastic tab is damaged or broken off, you need to discard that cable or you need to cut off that end and re-terminate it. The amount of troubles that show up in networks where a patch cable just isn't seated properly or isn't connected all the way can cause really weird intermittent sort of ghost in the machine issues. And I don't think that it's a good idea for you to keep that cable around. It's a higher risk than it is a return. Um, it's so hard to find when you're in a system whether or not those patch cables are fully seated. They look good, and the electrics are just not connected. So be really careful about tabs that are broken off. Um, Luckily for the rigors of production, we cover EtherCon. And EtherCon is a ruggedized connector that was built specifically for us. It has over 1,000 mate and break cycles, so there's no little plastic tab. It actually uses an active latch lock connection, like microphone connectors and other XLR connectors, to make sure that that's engaged and solidly clicked into place. So EtherCon is really, really good when you're doing networking for production. Also, when you're considering cables for production, consider that the cable be ruggedized, right? Solid core cables tend to break easily if they bend a lot. They're great for installation, but they may be difficult for portable cable. So look at maybe stranded cable. Also look at shielded cable as a way to reduce electrical interference as your cable may be running next to higher power sources. And then look at ruggedized jackets to keep out things like oil, dust, moisture, all those sorts of things. We do things very differently in production with networks than we do installing it in a building for internet and email and things. So make decisions that fit with the workflow. Quickly, let's talk about the idea of a network switch. The whole point of a network switch is to pass information between all the nodes and to minimize the traffic. And a switch does that by reading the destination of each packet. So if a node, and it's denoted by a green arrow here, is sending information to other nodes on the network, that packet of information is going to have a destination address. And the switch is going to read that destination address and send that out to the appropriate devices. So devices that don't need that, like the node that's on the left with just the yellow arrow, they're not going to receive that information, right? So the whole point of the switch is a traffic keeper, and kind of think of it as like a postal service, right? The ability to take information from one destination and send it off to other devices. Again, sort of a vocab lesson. We use the words switch and hub sometimes interchangeably. A hub is an older piece of network technology. They've mostly been retired. This was sort of in the very beginnings of networking that hubs existed. And they were very efficient because they took information from a single device and just duplicated it to all the other devices. So it was pretty much a one-way traffic pattern. And modern networking communications don't work that way. When we look at some of our protocols that the internet is built on, we need a lot of two-way communication and negotiation for a network to function. So hubs really don't work. And if you run into a hub in a legacy system, you need to assess whether modern networking technologies are going to work over it or whether it needs to be replaced. So again, switches and hubs are very different. And just be intentional about what you're talking about because they mean very different things. So when we're building up a network, we use what's called a star topology. Networks need a home run from every node to a switching device. So every node has a segment that goes to the switch, and the switch deals with getting information between all of the nodes. So we can expand this network to be as many switches, as many nodes as the switch can handle, and that will get us there. Any collection of switches and nodes connected together is what we call a local area network, or a LAN. So everything still needs to remain in the star topology, right? You'll notice on my right-hand side that there's no loops. Loops can introduce big problems into your system because the data just keeps circulating, and it can really crash your network. So everything only has one point of contact to the system. and we talk about star topology being expandable. We're going to look at a lot of other different topologies later on, including ring topology, which I know is a big discussion point. So we'll talk about that later. But anything that is a collection of devices together on a network is known as local area network. There's another device which is called a router, and a router sits between networks and can pass information between them. So you'll notice that the switch has the capability to talk to the router and pass information that's needed for a node on that other local area network. Routers are very specialized pieces of equipment. They filter a lot of information. So while they're really powerful, and their routers are pretty much the backbone of what the internet is, they can cause problems in a lighting control network. So we just need to be very careful when we're deploying them, and you need to kind of know what you're doing and what you're up to with routers. So that is some questions on some of the basic components. That is the basic components. Questions. Sam, do you want me to answer some of these, or are you going to read them out, or what are we doing here?
It's easier for you?
I don't know. Let's give this a try. This is our first one together, so this is exciting for all of us. Is the 100-meter segment only referring to PoE or both kinds of Ethernet? The 100-meter segment is for anything Ethernet. We'll talk about PoE a little later on, but the point is that you can't have a segment, regardless of what's going over it, that is longer than 100 meters. What types of cable does ETC currently suggest for its installs? That will depend on the category cable, but generally we use Belden cables. We can talk about that if we have some time at the end. Is there a link that can explain the relationship between Hertz and crosstalk? Maybe. Let me look into that for you. Hertz v. crosstalk. I guess one of the things that I should do is find a way to get things I don't know back to you all. I will find a way to communicate that to you, and I'll post it wherever this recording gets posted on the study team page.
We could set them for priority or something internally if we want to move those somewhere special to check after.
Oh, great. Yeah, let's set those aside then.
Okay.
Is ruggedized a spec or certification that can be met or not? Yes, but there are different ruggedizations for different industries. So it will depend on what your application is. Ruggedization for mining and underground work means it has to be explosive proof. For I want my Genie to be able to roll over it, there's different things. I don't have a comprehensive list of that stuff. But I would say looking at people who manufacture cable, things like SO and SJO are cables that repel oil and grit and things like that. But I'll try and find a list of something that's more comprehensive. Do you use a straight-through cable or a crossover cable? Good question. Crossover cables are pretty much dead. Everything that connects through a switch can use a straight-through cable. So crossover cables going through a switch can actually cause problems. So don't do that. You only need a crossover cable when you're plugging device to device, node to node, without going through a switch. And what a crossover cable traditionally does is it takes one side of the cable and flips it so that the receiving end is going to the transmit end on one side and vice versa. Most ports from anything that's been manufactured probably in the past 8 to 10 years is what's called auto switching. So it will, on first negotiation of those two devices, it will figure that out and they will communicate on the proper lines. So crossover cables are pretty much dead unless you have legacy equipment. So throw them away because they can cause problems. How does ETC feel about dual NIC devices that allow network pass-through? Well, dual NIC devices have separate network adapters. We'll talk about network adapters a little bit later, and you have to handle those as two separate network devices. If you're talking about using dual NICs on a single device as like a backup network, that is a whole other thing, and we're not really going to talk about that today. But if you send me an email, we can certainly do that. Or that can be an advanced network session that we can do later on. Do you expect that in the not too distant future, fixtures will move to ACN or similar? We'll talk about that a little bit later on, but not really, and we'll see why. What is an example of a lighting system that would use a router? We'll talk a little bit about some access to the internet. Some lighting systems are starting to get access to the internet. They need a router, and that's kind of useful. Also, lighting systems that are like a theme park lighting system that needs to interact with a lot of other business management systems and things like that. We want to get communication between networks without putting our whole network on their network. What are the current console NIC speeds? That will depend on your version of hardware. Currently, I believe we do gigabit on currently shipping hardware, but I think that goes back to 101000 or 10100 on some legacy ions and things. I'll have to look that up. That will be on all of your data sheets too. Does mate break cycle mean physically connecting and disconnecting of the cable? Yes. So a mate break cycle is when you connect the cable and disconnect it. How many cycles does the manufacturer of that expect that connector to last before it breaks? And 500 for RJ45, 1,000 plus for EtherCon. Yeah, importance of using the correct cable connector for the cable type. It's really important to use the correct connector for the cable you're using. Certain category cables have different gauges, and so if you don't have it connected to the right cable, you're going to potentially have intermittent issues. The cable could pull out. So you do need to get the RJ45 connector that is compatible with the cable that you have. Oh gosh, they just keep coming. I'm going to scan through this really quick. I'm going to cover some of this in a little bit in future sections. So I'm going to move on for now, and we'll try and get to some more of these questions at the next break. Cool. So moving on to the next section. So we're going to do a quick networking overview of Ethernet and Ethernet protocols. So Ethernet is a set of rules, right? The Ethernet rules define both the physical and digital components of a network. I think we use Ethernet pretty interchangeably to talk about a lot of stuff. Oh, this is an Ethernet cable. That's an Ethernet switch. Technically, that's all true. You often hear the phrase layer 1, layer 2, layer 3, layer 4. All of that stuff are different segments of the Ethernet protocols that define sort of the infrastructure of a network. So there's lots of different things that go into this. Learning all about all the layers of Ethernet is its own certification. So go to Cisco for that level of detail if you like. They have really good information on their website. But what we're going to focus on is some of the things that Ethernet is designed to do, and things that we use specifically for entertainment lighting and entertainment networks. And we're also going to talk about protocols. And protocols are what define the format of the data that's carried over the Ethernet, right? So protocols are sort of the actual language. Ethernet is more of a grammatical structure, if you will. It allows things to be transported back and forth, but protocols define what's actually being communicated. So the first part that we're going to discuss is the Internet Protocol Suite. The Internet Protocol, as a set of rules, is responsible for routing traffic through a network, so getting stuff from destination. You've probably seen several iterations. Internet Protocol version 4 uses 32-bit addressing, and you can see that example address, right? Hopefully we're all fairly familiar with this IP address, 10.101.0.1. On a single local area network, that gives you over 4 billion different addresses. So that's a lot of space. What's coming into popularity over the past couple of years is a new version of the Internet Protocol called IPv6. This uses 128-bit addressing, and you can see a standard address and a truncated address there. And I did this. This is a 3.4 times 10 to the 38th addresses. I don't even know what that level of number is called, but that's the quantity of addresses you can get on that network. So we're kind of sticking in entertainment networks to IPv4 because it offers us plenty of space, and you can really easily memorize really quickly an IP address or jot it down on a piece of gaff tape that's taped to your leg, and use it to roam around. IPv6 is very, very difficult to be human readable. It's really designed to be read by machines, and the scale that it offers is great when we're talking about sort of the global internet. For closed networks, we're kind of sticking with IPv4 because humans still need to interact and manage it, right? And there isn't really a compelling reason currently for entertainment networks to go up to IPv6. A lot of equipment and switchgear offers support for it, but consider how you're going to deal with it, manage it, document it, and interact with it. And I think this is a pretty compelling example of why IPv4 serves our purposes still pretty well. So digging through IPv4, there's actually a couple of different components to what's known as just an IP address, right? There's 3 components. The first is the IP address, which is the unique location of that device on the network. And I like to think of this as a postal address, right? If the whole network is a postal system, then every destination has to have a unique address, or else the whole system falls apart, right? If you have duplicate addresses on the system, then the core, the post office, doesn't know which one to send it to at any given time. So if you have multiple nodes that come on with the same IP address, it's called an IP conflict. And many systems, many switches will just stop communications with both of those devices. And oftentimes you have to rectify that and then restart those devices to get them to come back onto the system. So if you have a device that's not communicating, maybe look for an IP conflict and see if that's an issue. Other things, so quickly, yeah, you can have an IP address that's, the first octet is maybe the state, the city, the street. You can have all your addresses be in the same state and the same city, and in fact, we'll look at why that's beneficial in a moment. But you can't have a combination of the same street and house number. That will get you an IP conflict. You can have devices that are on the same street with different house numbers. You can have the same house number on different streets or in a different city, but your IP conflicts will come out of duplicates. So make sure that none of these things, all 4 of these octets, they can't be duplicated on your network. The next component of an IP address is what's known as the subnet mask. And the subnet mask allows a physical network, a local area network, to be sort of subdivided and let only certain nodes communicate with one another. And the way that a subnet mask works is that if an octet is set to 255 or on, not full, then the octet in the IP address must match between 2 nodes in order for them to communicate. So you'll see that in this example, my 255.255 indicates that my IP address 10.101 has to be the same across any node that I expect to communicate with one another. And this is called the network ID, right? This is what says these groups of nodes can talk to each other versus these groups of nodes. The rest of the IP address is known now as the node ID. And again, that needs to be unique so that you don't get any IP conflicts. So we want the network ID to be the same between all of our devices, and we want the node ID to be separate and unique so that all of our devices can communicate without colliding. So in a quick example, you'll see that this IP address it's got a network ID of 10.101.90.103. It's going to be good, right? It doesn't conflict with the node ID, and the network ID matches my IP address. If I bring on another IP address, the node ID doesn't conflict, but my network ID isn't the same. So those devices are not going to communicate with each other. This is probably one of the biggest problems of bringing new devices on a network, is you need to make sure that your network ID is set to the same so that they can communicate. We call different settings for subnets multiple classes. Class A is obviously the widest. You will have the most number of devices that can see and communicate with each other. Only the first octet has to match. This is commonly used for very large infrastructure networks. Internet service providers on their backbone will use a Class A subnet because they have a lot of control of the space. And they want a lot of devices to be able to talk. You can have about 16 million nodes talking to each other on a Class A subnet. In a Class B subnet, it's a middle of the road. You get about 65,000 nodes that can communicate with one another. And this is actually what we commonly use for control networks. It allows a little bit of flexibility and a little bit of organization, which we'll talk about in a second. And then finally, a Class C subnet, which is the tightest, right? You only get about 254 nodes that can talk, but it really slims down what devices are allowed to be a part of the network. And this is what's really commonly used for household networks. Your wireless router is going to deploy this kind of network, and private networks. So again, we're using Class B for a lot of our entertainment networks, and that should be your default unless you have a reason to change it. The other component, the last component of a IP address is what's known as the router or the gateway, depending on what software you're using. And this is used to define where in the network a packet should go if the destination IP isn't found. So this is sort of the all-call channel, the party line. And it just helps all the nodes and addresses figure stuff out if there's some miscommunication. It also can be a place where you direct traffic to a router so that it can send information between networks. That's not anything that we get into for the sake of today, but it can be used for that, so be aware. So there are a couple of ways that you can set IP addresses, right? The first is what's called static IP addressing. And that is where I go around to every device and I keep track of my IP addresses, my subnets, and my gateways, and I manually type those into every device, or I use configuration software like Concert or something. So this requires me to keep track of all this stuff and make sure there are no conflicts. So I get a lot of control, which is good. But it takes a little bit more work on my part. What's good about it, though, is in a standard entertainment network, we really only care about changing the node ID, right? Everything that's in blue here should be the exact same on every device that you have in your control network. We're only changing the last two octets of the IP address so that they don't conflict. And a lot of times we'll actually use those as organizational tools where maybe the first octet denotes the type of equipment it is, and then I have a unique ID for it. So .90s may be my control consoles, .50s may be my DMX gateways, whatever. I've seen people also use these to delineate what space a particular piece of equipment belongs to, right? If you're in a facility with multiple venues and gear kind of goes back and forth sometimes, but has a home space, this can help you delineate where that thing's supposed to live. So it's a good inventory management sort of scheme. So again, we're just making sure that there are no conflicts. And static IP can be really, really useful if you're using things like QLab or OSC integration or triggering UDP signals, because a lot of those have to be directed to an IP address. So we want to know that our console, for example, is always .90.101, so that as my system changes production to production, I'm not losing contact with those devices. The other way to deal with setting up IP address schemes on your network is what's called a DHCP, or Dynamic Host Configuration Protocol. Trying to manage static IP addresses for a small control network of 10, even 15 devices isn't too complicated. But as soon as you start to get into large or constantly changing networks, it gets really impossible to remember and manage those things. I don't know of many theaters that have a dedicated electrics IT professional. So those are things that that we all have other jobs to be doing. So Dynamic Host Configuration Protocol, DHCP, was created to allow a device to run the service, and as new devices connect, as new nodes come on, it calls out to the service and asks for credentials to join the network. So let's go through this with my coffee shop example, a not very obviously branded coffee shop that I may frequent. So the coffee shop problem is that I walk into a coffee shop to get my morning coffee, and while I'm there, I want to connect to their Wi-Fi and check out my email and go on social media and do all that stuff. If static IP addressing was the only way that networks functioned, the barista would have to go and find an IP that was available, decide who was still on the network and who wasn't, give me that IP address. It already takes me long enough to get my coffee. There's no way I would ever get onto their network. So this is where DHCP comes in, is the coffee shop puts a DHCP server onto their network. So it keeps track, it has a table stored in it of all of the available IP addresses that it's allowed to dole out, and you can configure that in a DHCP, and what device is occupying that slot, right? So as soon as someone goes to connect, it puts that in that slot. So if my iPhone comes on and wants to connect, the iPhone says, hey, DHCP, I want to join your network. I need credentials. The DHCP says, .101.2 is available. How about you have that? And then I get those credentials on my phone, and I now can talk on that network, which is great. DHCP automatically handles it. The baristas can keep doing whatever magic they're doing, and everybody's happy. But certainly in New York, there's thousands of people that go through one of these coffee shops in the morning. And, it's quite possible that this table could fill up really, really quickly. So DHCPs also have an additional feature, which is called a lease. And a lease dictates how long a device can sit in that slot before the DHCP wipes it out and makes that address available for another device to use. Right? If you've ever been in a coffee shop or a hotel lobby, and after 3 hours you have to reconnect, it's because the DHCP is set to a 3-hour lease. That is controllable by the administrator of the DHCP, and by default, all of ETC's leases are set for 10 years. The idea that you're not having the type of turnover on your lighting system that a coffee shop has, hopefully, maybe, I don't know what kind of hours you keep, but it's more likely that a DHCP is going to see a lot less traffic on an entertainment system than it's going to see there. You can also go in and manage this table, clear it out to reset the system, transfer tables and things like that. So that's the basics of what a DHCP does and how it keeps my coffee shop experience happy. But my iPhone was just called Nick's iPhone, and I'm sure there's a billion other Nick's iPhones in the world. So how does a DHCP server, before giving me a unique IP address, actually know my Nick's iPhone from the 15 other that have come in that morning? There's actually another thing called a MAC address, media access control. And a MAC address is actually a unique ID for every single port on the planet. So the IEEE, which is the organization that sort of supervises internet standards, as a manufacturer of a device that will have a network port on it, either a radio or a physical port, you can apply to the IEEE and they will give you an organization ID. So ETC, that's our real organizational ID. Anything we manufacture that has a network port on it is going to have the organization ID, and then it's going to have a unique device ID. So the IEEE keeps track of all the organization IDs. You can actually Google it if you're interested and have some time. It's interesting to go through and kind of look at who owns what organization ID. And then the manufacturer is required to make sure that the device ID isn't duplicated. So when we're manufacturing things like gateways, we have to make sure that all those gateways are manufactured with unique device IDs and don't get duplicated. If you have something like a console with 2 NICs, someone asked that a little bit earlier, 2 network interface cards, each of those has its own MAC address, right? So everything has its own MAC address. That is its own discrete port. And in fact, if you look at sort of larger manufacturers, IBM and Dell and things like that, they're going to have multiple organization IDs. You know, tiny little us in the entertainment industry, we are good with one organization ID currently. So again, keep kind of in mind that something like a cell phone, which has a 2.4 gigahertz Wi-Fi radio and a 5 gigahertz Wi-Fi radio, that's 2 MAC addresses. And those are unique anywhere else, unique from any other device anywhere in the world, unless you're spoofing a MAC address, which is technically illegal. Your cell radios will also have a similar idea. They're not IEEE MAC addresses. They're for the cell radios. Bluetooth has a similar idea for unique identifiers. And you know, even RDM has an idea that is for Bluetooth, right? So RDM has an idea that is for unique identifiers, so that there's no RDM device that has the same address anywhere in the world. MAC addresses and other components are often called UIDs or unique IDs or UDIDs. So they're the same idea, but for Ethernet, we use the MAC address to set those devices apart from one another. So I'm going to try and answer a few questions. I know a lot of stuff is coming in. We're going to try and go through a few of these.
You want me to just feed some stuff to you, Nick?
Yeah, that'd be great, Sam.
Okay. So, hello. Do you expect that in the not so distant future, fixtures will move from SACN, will move to SACN or similar?
It's a good question, and we talk about it all the time. I actually have a little bit in the presentation a little bit later that we'll talk about fixtures with RJ45 ports. So we'll talk about that in a little bit.
And then just because we have kind of touched on larger systems earlier, do you know of any research to learn about specific routers for larger networks, or should we say if the router is good enough for home use, then it's good enough for large systems?
I actually will say the opposite, and again, we'll talk about this in a little bit, but routers that are made for commercial use or home use tend to be purpose-built and non-configurable. They tend to you know, make things like streaming video and playing games online and looking at cat memes. Like, they tend to prioritize those things and make them easier to deal with. you're getting into routing information between multiple networks, gosh, I'm trying to think of any resources that are in the entertainment lighting world that cover specifically our needs. A lot of times that gets to like an IT level of interaction. So if you have more specific questions, I'll make sure to leave my email address at the end of this, but it's nick.gonsman@etcconnect.com. If there's specific applications that you're looking at, maybe we can have a conversation about that sort of stuff. But if you're trying to route information between networks that isn't like show control based, we should have a conversation about how routers actually function. But definitely, if you are doing that, you'll want to use professional level routing equipment, because then you can configure it and turn off all the stuff that blocks the stuff that we care about.
Brian would like to know, what are your thoughts on supporting multiple protocols such as SACN and Dante on the same network?
Yeah, sure, sometimes. It's all going to come down to bandwidth and the throughput of your switchgear. Depending on how much time we have, I have a little bonus thing on VLANs. We can also, because we all have a lot of time right now, can schedule maybe a level 2 network training. Generally, though, we're saying no. For the purposes of basic control networks, we want a discrete lighting network. We want a discrete sound network. We want a discrete video network. Again, this is an intro class, so of course those rules can be broken, but you have to really know what you're doing, and that's kind of out of the scope. So technically, yes. For the scope of today, no.
2 questions about network addressing that I think are kind of related. The first is, do the consumer switches know about the special 2xxx and 10.xx addressing for ArtNet and SACN? And then also, some venue networks that this person is running into will run 192.168. Are there situations where you should be switching those subnets for ETC equipment?
Yeah, so technically, consumer grade routers, consumer grade switches, as long as there's not a router involved, and we'll look at that, if they're just a flat unmanaged switch, they should just pass the information and not care what any of the subnets of the IPs or anything are. So if there's a reason to put your scheme at a 192.168, that's fine. 192.168 is what's commonly used for internet access. And so the reason that we use 10.101 as a default network scheme is because that's considered by the IEEE to be a private network scheme. And it prevents things that are looking for the internet from interfering with our stuff. So, somebody accidentally connects to your Wi-Fi or accidentally connects a hard port. If that device is in a 192.168 and the rest of your network is in a 10.101, because of subnetting, you're automatically ignoring that device and it's not interfering with any of your stuff. Sometimes we have to architect systems to go on corporate networks or to do some other things that it has to be in the 192.168. Most entertainment gear nowadays doesn't care what subnet it's in. It doesn't care what the IP addressing is, as long as they're able to communicate with each other. What we worry about is other devices either accidentally or intentionally getting on our network and interfering with our devices. Again, risk averse. We want to make sure that we're doing everything we can to prevent anything from going sideways on our network. Does that kind of answer that?
Yeah. And then let's see, is there a good way to use DHCP in a lighting system, or should we stick to static IP addresses?
It's a good question. I've got a segment a little bit later on about which to choose, so we'll cover that.
Let's see. We have an adapter that can translate XLR to RJ45. Oh, and then it's gone. Oh no, question's gone. Sorry,
I see it. We have an adapter that can translate XLR to RJ45. We use this. It will. So converting DMX over to Cat5. there's two things going on here, and this is Osman, I think. Hi, good to see you. So it's important to remember that Ethernet, which uses category cable, Cat5, Cat5e, Cat6, is not the same as DMX over category cable, right? When we convert RJ45 to 5-pin, or the other way around, what we're doing is we're actually taking the DMX signal, which is a serial RS485 signal, and running it over those cables, right? So the distance limitation in that case is generally the distance limitation of DMX based on the gauge of your wire. So at 24 gauge, you may start to run into problems. So technically, DMX over Cat5, if the gauge is proper, can run the 1600 feet that DMX can run. However, it is often a lower gauge, and so I tend to recommend only 300 feet. So if you're installing a system and you can guarantee that the gauge of the wire is sufficient enough to run the 1600 feet, go for it. If you're not, then stick to 300 feet. The other reason that sometimes we'll still run DMX lines in a theater when we're building a new theater or a new studio, because it is for the needs of the space, but we want to future-proof it. So because we can run DMX over Cat5 or any category cable, we'll actually run the Cat5 in the wall with the hopes that long-term, if stuff moves to Ethernet, they can just pull out the connectors, clip them off, terminate them with RJ45, and now you have a network run, not just a DMX run. Again, you'll need to make sure that when you're pulling that cable, that it all fits within the 300 feet or 100 meter maximum length of network, even if DMX can go 1600 feet. A long answer to a short question, sorry.
That's okay. Do you want to answer a couple more, or you want to truck on through?
Let's do a couple more. We're okay on time, okay. I think.
Great. So this person is wondering, so they're using an LN2, and they're asking if they need a node to use a backup. So I guess talking about backups and systems might be helpful.
Yeah, it's a good question. When you're talking about a backup console, you know, two consoles that are automatically tracking each other, and if one fails, the other automatically takes over. You do need a gateway as part of the system, because if you have console A and console B, and you plug your DMX into console A, and it's the one that fails, console B has no way to talk to that DMX, right? You're physically connected. So the idea is that if you have a little network switch and a gateway and the two consoles connected, that if console A fails, B can still talk through the network to the gateway. So yeah, you kind of need a gateway in that if you don't have a gateway, it sort of defeats the purpose of having a backup, right? If the console tips over, then you have to physically start moving DMX ports, and sort of what was the point. So yeah, we generally want 3 devices in any sort of backup scenario.
There are a couple questions about the differences between managed and unmanaged switches. Do you want to cover that now or later?
Yeah, I'm going to cover that later, and if we still have questions over there, we can talk about it.
I also think Colin's question about recommended practices for a single NIC connection to a sound console, that might be something in the topology that we might be able to squeeze in.
Yeah, so again, because each NIC, each network interface card or NIC NIC, not me NIC, but NIC NIC, because they can be configured to different IP schemes on a console. If you have 2 on a console, one can go to your ACN or ArtNet or whatever, and the other can be configured to go to a sound console. And then in the settings of like EOS or whatever, you can turn off all the non-relevant communication. And what the software is going to be able to do, the EOS software that's running above both of these network interfaces, is take information from the sound console that it needs, just the information that it needs, and it's going to manage the information to output, you know, level data for lighting and things like that. So the reason we put 2 network interface cards on a console is so you can sort of make those split decisions. It's a bit advanced for what we're going to talk about today to get into the details of it, and it also is on an application by application basis. But that's why we moved to putting 2 network interfaces on every console, is so you have that flexibility to not have to do super crazy stuff at your switch. You can just come out and go to a different thing. We consistently see ArtNet, because ArtNet often needs a different IP scheme. ArtNet 2, I believe, really likes the 192.16h scheme. You can set one port to do ArtNet and the other port to do ACN. So that's a way of using those 2 ports separately. Yes, it can be done, a little out of the scope as to digging in deep about that. But again, maybe we do something like that at a later session.
Great. How does ACN communicate through different subnets?
Yes. Technically, ACN is subnet agnostic. I'll punt this question to we're going to talk through what ACN is. It's a little technical. You should be setting all of your devices to be in the same subnet, but technically, ACN is subnet agnostic. It should be able to be read by devices in separate subnets. We'll talk about that in a little bit, but good working practices is making sure that all your devices are properly configured to be in the same subnet.
Why does ETC still default to a screw terminal connector on DMX jacks and other DMX devices when 9729, et cetera, are so cost prohibitive versus Cat5e?
For DMX, it's because DMX is still the better cable, right? So DMX is a serial protocol, and 9729 is built for serial communication. Again, USITT ratified the ability to do DMX over Cat5, and people do that, but it's not ideal. If you're an installer tech, and I don't know if it's on our parts store or not, but you can get access to a special termination kit for category cable. So you'll just need to request that from your project manager, or if you have questions about it, if it's not on our store, you can Google it or ask me. But the fact of the matter is that 9729 is a cable that's designed for that signal. So we still recommend that be pulled if we can, because there's a lot of caveats, as I was mentioning earlier, if you start pulling category cable for DMX.
And related to Cat5 for DMX, Bill Connor wants to know, do bend radiuses apply to that?
That's going to depend on your wire type. As I kind of mentioned, solid core wire, especially as you start to get into larger gauge cables, like category 6 stuff, a larger bend radius than stranded stuff. So you need to read the data sheet and go by the manufacturer's recommendations based on that cable. Not all cables are equal.
When hooking up a client, which is better, using a router or a switch, or direct from the console to the backup, which I think we touched on this a little bit a moment ago?
Yeah. Let's be clear. For the sake of today, you do not want a router in your system. A router's job is to block traffic and permit only specific pieces of traffic. Unless you really know how to get under the hood and manage that, you want just a switch. And we're going to talk about unmanaged versus managed switches in a little bit. But basically, we want unmanaged dumb switches that all they're doing is passing information from one node to the other with no regard for what the content is.
Earlier, you mentioned how we don't want to share the lighting network with any other devices. What about use of Dante and lighting on the same network?
We kind of covered that. If I would say by default, they should be on separate networks. And if you have communication between the two systems, that similar to how we talked about with the sound console example, you need to use a separate network path for that. But that gets into managing things that I think is a bit out of the scope of today. So for the sake of today, everything should be separate: lighting, sound, video, COM, all that stuff should be on its own separate physical network. And I think based on the questions, we might want to do a maybe more advanced network in the next couple weeks. So I'll make a note to maybe start putting something like that together.
And then one last question. Any general guidelines to consider when selecting Ethernet DMX gateways? This specific person is having issues with Chauvet products, but then other manufacturers' products are working fine. So maybe just talking about how we make those considerations.
Yeah, that's tough. You know, we'll talk about protocols in a little bit. ArtNet gateways can have, probably because ArtNet isn't always ArtNet, there's a lot of accents in ArtNet that some devices not communicate well with others. So, and ACN is a pretty rigid protocol. So as long as the device is fully adhering to the ACN standard, then you should be pretty good to go. You know, one of the things to consider when you're buying components for your system is that, you know, the reason certain pieces of equipment cost what they do. Let's take a gateway, for example. If you have a network, that network port is responsible on that gateway for getting all communication back and forth between the network and the electronics inside. So if that's a low quality network port with not a lot of throughput, there's going to be a lot more errors that are developed, and the network's going to have to resend information to that port multiple times. So I won't say it's always a get what you pay for, but it's a little bit of a you get what you pay for. The reason that some of the premium products cost more is because they have higher quality components built into them, and higher quality components in a real-time environment are going to behave better. So if you're looking at something, I guess the only thing that I can suggest is to try and get a demo from the manufacturer, make sure it's going to work on your system. Maybe only buy a single one and test it out for a little while, and see what the manufacturer's service is, right? Like if they're gonna sell you a piece of equipment and then it doesn't work and they're not fix it, that might be a thing to look at as well. You know, I know that ETC gateways tend to be one of the more expensive ones on the network, but you know, you could like actually through them and they're gonna live. So budgets are always difficult. You know, sometimes you want a very decision, but as a critical component to the operation of your lighting system, consider how much you're willing to reduce your budget versus how much you need something to operate flawlessly and all the time. There's no like guaranteed metric to say, dude, it will always work. Some devices aren't always going to be able to keep up with the readers, and it's unfortunate. Sam, you said that was the last of this segment?
Yeah, I think we should push ahead, and then because I think some of this stuff might get covered a bit later. So I think let's push forward, and then we'll see what.
Great. We've got about 45 minutes of our scheduled time, and I feel like we're mostly on track, which is good. So, so we'll keep going. Thanks everybody for hanging in there. I hope this is informative. So we're going to talk about the other side of TCP/IP, which is the transmission control protocol. So all of this stuff was, you know, Ethernet was built for the internet, right? And so all of this stuff was really to support email and web page facilitation and, you know, cat memes, which are the most important part of the internet. So these things are systems that are designed, and I highlighted it, for reliable, ordered, error-check delivery that is optimized, accurate, rather than timely delivery, right? So this is something that's really important when we go back to our thesis statement of why do we create entertainment control networks, and one of the main goals was that it be real time. So as I used in the example earlier, if your email is a couple seconds late one day, it doesn't matter. If your go button presses a couple seconds late to your node, then you're fired, right? So so we have to do some stuff knowing this to kind of get around it. And we'll talk about some of that stuff in a little bit. But TCP is really designed to make a reliable stream delivery service. So it makes sure that when you're receiving your email, all of the words are in the right order. All of the pictures come together in the right size. All of your video is streamed in the right frame order. So it's really, really good for putting together internet stuff. But oftentimes in a control network, we don't have time to wait for the receiving device to put that back together in the way that it needs to be assembled. So from the get-go, we're finding protocol that we use on the network. And we'll cover that more in a little bit. This is a joke about TCP. This is actually how nodes communicate to ensure accurate delivery, right? There's handshaking, negotiation. There's a little bit of what's coming, here's what you should expect. So this is a very nerdy joke, but I think it gets the point across as to how TCP connections function, right? The other option for is UDP. It's often just called UDP. UDP/IP is technically correct. Nobody calls it that. It's the user datagram protocol. And this doesn't require any handshaking. This doesn't require any established connection between the two nodes before data gets sent. It is simple, connectionless, but with no guarantee of delivery or order, or if there's duplicates, right? It just shouts stuff out to the network. And if the receiving node gets it, great. If not, nobody knows that there was an error. This is similar to how DMX works. DMX just streams information 44 times a second, and EMX, the console, never knows whether or not the fixture or the dimmer actually receives those messages. It just keeps sending it. So a lot of times we'll use UDP in entertainment control for show control systems. But again, kind of run the risk of that. If a UDP message is critical, there is a risk of losing it on network. So just be cautious about that. But the UDP is really, really simple and easy to do. The UDP joke, a joke about UDP, but you might not get it. So there are a couple of message types as well that go through here. Broadcast is a message type that sends the data to all devices on the network, right? In its basic form, it just kind of sends everything out, whether it's useful or not to particular devices. And so for that, it can unnecessarily clutter the network, right? It's just kind of getting stuff out, and it's not directing traffic very well. So a lot of switch gear, if it's not configured properly, will be broadcast as spam and lock them down and not pass them on. So it's important to rely on broadcast in order to get through. Unicast is it's a single destination. It sends the same message to each device that wants it. So for 200 of you, it would be like me sending the exact same email to each and every one of you, as opposed to CCing you on the same email. So it can use a lot of resources on that, where if you are a lot of the same information to many devices. So if I've got a console and I have 15 gateways that are subscribed to Universe 1, I'm now sending the messages. So and some devices rely on unicast, so you need to know that that's there. And then multicast is a protocol that can do a single to many. And I like to kind of consider it like an RSS feed, right? Where there's a virtual IP address that lives out in the network, and any client that wants to contribute to that feed can send it to that IP address. Anybody that wants to read that feed can subscribe to that address. So it takes the strain off of putting a whole lot of information on the network, and really helps manage the bandwidth, right, and keep it slam and effective. Again, sometimes multicast can be viewed as spam, so we want to make sure that our switchgear is passing on and allowing function for our protocols to go through. Do we have any quick questions about the TCP or UDP side of stuff? Okay. We'll kind of reflect on this stuff as we go through.
Nothing specific to that if we want to keep going and just do general questions later. Okay.
Yeah, that sounds good. We got time for that. Let's do a quick lighting protocol showcase. These are some of the protocols that we use on a TCP IP network to communicate lighting data between devices. So the first is ACN, or Architecture for Control Networks. And ACN is a suite of tools. So ACN in itself doesn't communicate any information directly between devices. It's a conduit for stuff to pass through. So what we'll look at in a second is streaming ACN, which is a protocol within the ACN world that allows the streaming of lighting level data. Sound manufacturers and communications manufacturers, headset manufacturers, are building some ACN suites so that their devices can communicate with each other. The whole point of ACN is it's sort of the playground for entertainment devices, so that we can bring people onto the same network, so that there aren't conflicts, so that everybody can be happy and not collide and get into trouble with each other. So that's the intent. And you'll see more and more sub protocols kind of coming out of this standard as time goes on. The first to be ratified was streaming ACN, and streaming ACN is getting lighting levels across the network. You know, it's DMX over ACN. So it is streaming. It uses multicast and it is UDP, right? So much like DMX, it's just going to continue to send UDP messages, but because it's streaming and constantly updating those levels, it doesn't matter if the packet doesn't get there because there's another one directly behind it, right? So that's how UDP is useful in a situation like this, is the packet wasn't just sent out once, we keep updating it. Streaming ACN uses virtual IP addresses, like I mentioned. Again, there's 65,000 plus possible universes that are available. And it uses priorities to decide which contributor wins. So if you have an architectural lighting system and an entertainment lighting controller, those things can be set to different priorities, and that can affect how your ACN is received and translated on the side. So we see ACN a lot. It's a modified standard, and I think this is kind of important. ANSI, which is the American National Standards Institute, I believe is what it stands for, has ratified this as a government standard, and that's adopted by a lot of other governments around the world. So an advantage of this being a government standard is that it's really well vetted, and it's highly likely as a consumer that if you buy ACN devices, as I was just talking about, they're highly likely to communicate with one another. As long as they've implemented the standard to its specifications, everything should work out. The disadvantage is that change is slow, right? Like if there's a new idea, you have to go through the government steps, all of the sort of red tape to get changes implemented. So innovation can be slow, but as a consumer, it sort of protects you and knowing that it will function when you need it to. RDMnet is a recently ratified protocol of ACN as well. So it in 2019. It's been around being ratified for a long time. Again, it takes a lot of time. So basically, it allows all the information that's in an RDM packet on the DMX line to be encapsulated and brought onto the network, and vice versa. So it's an open protocol that allows RDM communication over the network to no longer be manufacturer specific. Again, if you wanted to use RDM with an ETC console, traditionally you've had to use ETC gateways because we were controlling that packet between those two devices over the network. Now there's an open standard, and in theory, as stuff evolves, again, this is brand new, so it'll take some time, you should be able to use anybody who uses ANSI E133 to be able to get RDM through the gateway. It also provides for some special messages for configuration of DMX gateways. So that should reduce the need for, again, proprietary software. Consort could be used to configure other gateways that support this standard. So this is brand new. It takes people a while to develop software, especially in these times. But look for that kind of on the horizon. The industry as a whole is going to get a lot more compatible with RDM and not just kind of turn off. That is another common protocol. ARTNet is a proprietary communications protocol. It's not a government standard. It does go over TCP IP networks, and it's owned by Artistic License in the UK. So, you know, one of the kind of apples to apples, one of the not being a standard is that sometimes certain groups of manufacturers can speak better to each other than other manufacturers. So if there's a feature with like a media server and a console that's really, really awesome, another media server may not have that same feature with that console. So it's a little bit more manufacturer-centric in getting cool things to market fast, which is great. You get a lot of innovation, but as you go shopping for products, you may not have the breadth of access to features because there are a lot of different flavors of even versions of ARTNet. So just be really aware of that if you're looking to deploy ARTNet. Can the two devices that I'm looking to deploy actually communicate the way that I expect them to? It's a little more, you need to take a little bit more precaution when you're dealing with ARTNet. Versions 2 and 3 used unicast and UDP. They had a theoretical limit of 32,000 universes. Some were able to push that based on routing. But version 4, which was recently output, I think they ratified it late 2018, I believe, uses streaming ACN to transmit the lighting data. So all of the information that is device communication is still there, but lighting level data has now moved over to ACN. So that's actually a really good thing because now ARTNet version 4 will work with ACN gateways. So there's a little bit more compatibility coming to the general product offerings. Again, the advantage of ARTNet is that you can get a lot of really interesting stuff fast. ARTNet has been really good about introducing new features between manufacturers that ACN has been slow to implement. So you just need to be cautious as to which one you want to look at. And again, be a really smart consumer when you're looking at how devices work. ARTNet and ACN can live on the same network. The big thing is that if the ARTNet version is allowed to live in the same subnet as ACN, or if you move your ACN over to the subnet of ARTNet, they won't collide. They will live on the same network and politely ignore each other, right? Devices that don't speak ARTNet will just ignore the ARTNet. Devices that don't speak ACN will ignore the ACN. But you need to make sure that your IP scheme is going to be acceptable to both sets of devices. So just be aware of that. Another protocol that you may run into are ETCs Net2 and Net3. Again, these are proprietary protocols, but are based on industry standards, similar to ARTNet version 4. So Net2 is kind of moving out to pasture. It's still in some places, but ETC hasn't made Net2 devices in over 15 years now. So it's still installed in some places, but it's slowly being replaced. We use EDMX to carry the lighting level data. And EDMX as a protocol was the first TCP/IP standard, and it just carried addresses 1 through 32,000, which meant there were no designations for universe. So, what does it mean when you need 22/223, or what does it mean when you need to address 12,373? It was really hard because at the end of the day, when you broke it out, it was still on a universe. So when ACN was being developed, that was a big informant. And again, ACN uses universe/address so that it's more human readable. So there's a priority structure just like ACN, but it's got 20 steps instead of 200. For Net3, it's built in ACN, so the Net3 protocol lives in the ACN wrapper. And it uses streaming ACN to carry the lighting level data, right? So as we go from our console to our gateway, that's streaming ACN. Any streaming ACN capable gateway can pick up that same stream. We also have been doing RDM again in a proprietary wrapper that will move to the RDM net in a while. But we also live alongside protocols like DHCPs, domain name services, time synchronizations like MTP and SNTP. So Net3 is a fuller suite of stuff that isn't necessarily ratified in any sort of other thing. So that's kind of what those two protocols are if you run into them. ETC devices speak them. Some other manufacturers' devices speak, particularly Net2. I know Grandame 2, I believe, speaks Net2. You have some other manufacturers that have accepted these proprietary things into their systems. So that's kind of that. What questions do you all have about control protocols before we go into actually building an entertainment network? Yeah, Sam, what do you got for me?
So I have some protocol questions and then some hardware questions. Do you want to save the hardware questions for later or deal with everything now?
Yeah, let's just do the protocol questions. Let's save the hardware questions and see what we cover in a little bit.
So Jason Cochran wants to know resources for UDP for using it to communicate between consoles and other devices.
Yeah, so UDP, it will depend on the device. For EOS family consoles, there's a defined language, and you can find that in the manual under the show control guide. So we have a defined language that you can say, you have to send us this UDP signal for channel 1 at full enter or whatever. Products like Paradigm allow you to define a UDP string in an event handler. So you can say 1AF, if I receive that UDP string, it turns my zone 1 to full. So it will depend on the product that you're sending the string to and what it needs to hear to activate. So for EOS, look in the manual. I would say for other products, start with the manual and see where you get. But it's going to depend device by device.
Thomas would like to know, does the SACN priorities behave more like HTTP or LTP?
Good question. So there's two levels of priorities. There is a per universe priority, which says if Rob Crane has a higher priority than I do, and in most things he does, and he's outputting address 1 in universe 1, then all of his contributions for universe 1 wins over mine. So even though the rest of his universe is 0, if I'm outputting levels, because his per universe priority is higher, he's basically stomping out my full universe contributions. There's also a per address ability from some devices, which says Rob can have addresses, the first half of the universe is at a higher priority, and then the second half of the addresses are at a lower priority. So some devices allow you to set priorities based on an individual address. when priorities are equal on a network and this is two devices contributing to ACN, right? So if I've got a paradigm processor and a hog or whatever, right? My gateway is the one who's arbitrating this. It's receiving both contributions, and it's opening up the packet and saying, my paradigm priority is higher. I'm going to let it win and throw away my hog contribution. When the priorities are equal, it is generally a per address HTTP, right? So whatever address is highest between the two sources will win. There's some devices that deal with that with, again, you can do some complicated if-then statements in a paradigm system based on the level of addresses and resetting priorities. But by default, if the priorities are at the same, the gateway is going to arbitrate those on a per address HTTP basis. I hope that answered that.
Along the lines with per device priorities, Matt would like to know, are these part of a standard, i.e. if you're working with different manufacturers, do they all support that same concept?
Yeah, correct. Yeah, it is always that, I didn't put once again, my priorities are lost, story of my life. The ACN priorities go from 1 to 200. I didn't put them, there I go. And so all devices that implement streaming ACN, 200 is the highest, and 1 or 0 is the lowest. So again, the gateway is going to be the one to arbitrate that. So any device that includes a priority in their streaming ACN packet, the receiving device will be able to arbitrate that. So that's part of the streaming ACN standard. So yes, as long as it's fully implemented, this should work with any device that speaks streaming ACN.
Moving to ArtNet, how can you see if a node is outputting ArtNet 2, 3, or 4 protocol?
Gosh, ideally it will tell you. And this is, so again, let's delineate this here. There's a console which is outputting or contributing ACN to the ArtNet to the network. Ideally, in the software or in the documentation, it would tell you what version it's outputting. Some documentation is not created to all documentation, so it may or may not. If you're trying to determine what version a gateway needs to hear, again, the documentation is going to tell you. With an output device, you can use a tool, a wire sniffing tool like Wireshark or some other wire sniffing tool to sort of go in and sleuth what packets are on the line. I honestly don't know if there must be an ArtNet sniffing tool that's out there that makes this easier. I just don't know it off the top of my head. But yeah, you're going to have to go figure it out through the manual or sniffing the wire. If you're trying to figure out what version of ArtNet the gateway needs in order to listen to the ArtNet signal and output DMX, your documentation is going to have to tell you. If it doesn't listen to the ArtNet, you can either try and output all the various different types of ArtNet from sources that can contribute it, or you can read the documentation. So
people are chiming in that ArtNet Nominator is the tool of choice.
ArtNet Nominator, amazing. Thank you, everybody.
I liked the sequel a lot better. I don't know. I think that they did a better job with the robots in the sequel.
Yeah. ArtNet Nominator to Electric Boogaloo was really the key one there.
I have two questions that I think will kind of tie together nicely, staying on the ArtNet topic. So Thomas would like to know if there are best practices when using SACN and ArtNet on the same network. And then Gregory was wondering the purpose of limited versus directed ArtNet options in the console, just like they have in EOS.
Yeah, copy that. Without going too far into the weeds, again, as long as all of your IP schemes can get together, right? If you can find an agreeable IP scheme for all of your ArtNet and all of your ACN devices, there should be no reason that they don't work. So I'm trying to remember where the break was. I think version 2 likes the 192.168 and version 3 allows you to pick your subnet. But really all it comes down to is making sure that they can all communicate with each other. And again, devices that don't speak ARTNet will politely ignore the ARTNet signal. Devices that don't speak ACN will politely ignore the ACN signal. If you're running into troubles where you can't set up your network that way, then we need to look at multiple network NICs, right? Or dealing with some special stuff on the network. That's a little out of the scope of today, but it is possible. But ideally, the quickest way to do it is to get everybody into the same ecosystem. Because again, ACN devices don't care about ARTNet. ARTNet devices don't care about ACN. The second part, Sam, what was that second part again? I'm sorry.
The second part, so a question to tack on, and then it'll be related. So the original question was talking about direct versus indirect options for ARTNet on consoles, which we have in EOS, but also people are chiming in and are wondering what version of ARTNet outputs out of EOS consoles currently.
Sure. So the direct versus indirect is your broadcast versus unicast. So away you go. I think, and I'm probably going to be misquoting, I think we're still on version 2 of ARTNet. I know there's been lots of discussions about moving forward, but that's why there's that choice in there, is because version 2 can do broadcast or unicast. I'm going to go on record as saying that we're doing version 2 still, and then when I get corrected, I'll, I don't know, I'll yell a lot and hope people hear. We've been talking in development meetings for a long time about bringing in version 3, but also version 4 starts to use ACN for the lighting level. So like, do we just use version 4? I'll get some clarification on that and try and post it somewhere useful.
And then we're gonna do a half pivot into SACN and then a full pivot into SACN.
All right.
So our half pivot is if Connor brings up, if ARTNet uses SACN anyways, then is there ever a reason to use just SACN output, assuming your devices are ARTNet compatible?
Sorry, I think I understand the question. Not all versions of ARTNet use ACN for their level data, right? And ACN also, and ARTNet also has a lot of other communication that isn't just the level of the lights, right? The DMX over the wire. There's a lot of other things that can be communicated over ARTNet. Media servers can pass thumbnails back to consoles. There's all sorts of stuff that is in ARTNet that isn't just the lighting levels. So, if you're just using gateways that use version 4 of ARTNet to output to DMX, sure, there's actually, it doesn't really matter, I don't think. But if you were looking to use ARTNet for any of those other things that ARTNet does, then obviously you'll want to make sure that that's part of your system. So just remember that, all the proprietary ones contain a lot of stuff. Even the non-proprietary ones, even ACN, contains stuff that isn't just lighting level data, right? It does contain lighting level data, but it also transmits other information. If that answers the question.
Let's see. I have one more ARTNet question, unless you want to move on to SACN.
Let's do ARTNet real quick, and then we'll move on.
Okay. With ARTNet 4, when it's on the same network as SACN, because version 4 uses SACN, will lighting levels clash between the ARTNet universes and the SACN universes?
They shouldn't, right? So if you have a single console, again, and what we talked about with ACN is a subscription-based, right, like an RSS feed. So if there's a single controller that's contributing to a virtual IP address for Universe 1, and then an ARTNet device is using ACN streaming ACN to subscribe to that IP address, and an ACN device is using streaming ACN to subscribe to that address, you shouldn't have any issues. But if you run into issues, you might want to start looking at kind of what's going on in the network. Are there other things happening that cause the data to have issues? But by default, because both of those devices are subscribing to an ACN IP address, it should be pretty functional.
All right, I have two SACN questions right now. First is, can RDM function only over SACN without being first converted to DMX?
As in, if you have a fixture directly connected via network to, instead of going through a gateway. I think I understand the question. I'm gonna expound upon this a little bit. RDM is a signal that can't live alone. It lives on a DMX line, right? It lives on the same electrical pairs as DMX. So RDM, as it's defined, lives exclusively on a DMX line. Up until E133, once it got to a gateway, the manufacturer of that gateway packaged it however they wanted to get it up to the controller so that that communication leg was handled. So that's what RDM 133 is standardized, is it says we're all going to talk the same language so that it doesn't matter if it's my gateway and my controller or if it's another manufacturer's gateway and my controller. As software evolves to accept this standard, that part of the path should be able to be non-proprietary, which up until this point it has been. So far as a device being able to use RDM, you know, there are fixtures that are coming out that are plugging directly into the network and are using various protocols. I think that'll be on a by fixture basis. And I think that RDMnet is a little new for a lot of manufacturers to have implemented it. So I hope that answers the question. But the question is, if a fixture plugs directly in, maybe that will depend on the fixture implementing RDMnet. But RDM can't live outside of a network without DMX, I guess is the point.
Is there a best practice to solve control conflicts I have with the same ACN priority between controls like Paradigm and EOS? That's
so specific to your install and your implementation. One of the things that Paradigm can do is dynamically change its ACN priority based on certain states. So one of the things might be to get someone in to help you program, when my console turns on, I want the Paradigm ACN to drop so my console takes priority. I want all of my performance lights to not be included in my Paradigm processor. There's 100 ways that you could do it. But EOS family consoles right now do not have the ability to dynamically change their priority of ACN. You have to go out to the shell, change the priority, and then come back in at a new priority. But Paradigm has that ability. So with those two products, the Paradigm side would be the one that would do it. If you have further questions, I'm happy to take an email and we can start discussing that stuff. So.
I have some ETCnet and Net2 and Net3 questions.
Yeah, let's do a couple of those.
Yeah. As an ELEC in an older space, do Net2 and Net3 compete with each other? New Ion console with original Net2 nodes, adding in some Net3 devices.
No, so Net2 and Net3, just like ArtNet and ACN, live on the same network peacefully together and ignore each other. So you can have both of them streaming. If you are on your Ion, you can check those boxes and it will output all of those, and they should live pretty harmoniously. Yeah, I think that's it. I can't think of anything that would conflict.
Okay. Tyler is wondering, will existing gateways be compatible with RDMnet with just an update, or will it need better hardware? I know this is probably just specific to the piece of hardware he's talking about, because our current generation Mark II gateways all support RDM. Yeah.
Yeah. All of the gateways that ETC has made in the Net 3 or the response line can support RDM with a firmware upgrade. What I am unsure of is whether supporting RDM Net, if there's a generation of hardware that won't support it. I'm unsure. I know that RDM Net has been being discussed for a really, really, really long time. We're a standards loving company, so we try and follow standards where standards are available. So it wouldn't surprise me if we've been kind of following the rules even way before it was ratified. But I don't know if there's a generation that would be updated. I would say that would be maybe when things are calmer and when things start to get back to normal, taking a serial number and giving phone support a call would maybe help them determine that for you. I haven't heard of any cutoffs, but I don't know, honestly, whether that requires a physical hardware upgrade or whether we're going to do a firmware upgrade that will cover everything to get RDMnet functional. Sorry about that.
And the only other question I have that is not directly kind of hardware in my system related is Ruth asked, how do you update ETCnet? Does the cable have to be replaced? And so maybe there might just need to be some clarification there.
Yeah, the answer is maybe, right? Depending on the age of the system, again, we talked about hubs versus switches. Some very early ETC net systems before Net 2, before Net 3, went in with a system called ThinNet, which was on Category 3 cable. I think that you'll want to get a hold of a local dealer or ETC support. You'll need to know what the wire type is in the wall, because the answer is maybe. If the wire type can support modern networking, you're good to go. If it can't, we might need to look at other solutions. But we need to know what's in the wall before we can make that determination. Cool. Shall we move on?
I think so, and then we'll just wrap with a couple last minutes for questions when we get to the end.
Yeah, so I know that my time is up in about 8 minutes. I'm going to keep going. If anybody wants to stick around, you're very, very welcome. Again, this is being recorded, so if you want to come back and check in to finish it, if we can't get to your questions, feel free to email me. Again, I'm happy to try and filter that stuff to the right place. And if you're interested in the hog, don't forget that hog starts in 8 minutes, 7 minutes. So feel free to hop off and know that this will be recorded. Basically, what I've been talking about up until this point is all the stuff that you need to know for us to start making decisions about building an entertainment network, right? So I'm not looking at all the questions. It looks like we have a lot, but I hope that this will clarify a good portion of them. And if not, we'll cover some stuff afterwards. So networking is here to fight us, right? Like, remember very early on when I mentioned the whole fact that Ethernet protocol is optimized for accurate rather than timely delivery. That's a problem for what entertainment networks need to do. So from a theoretical standpoint, the decisions that we make are really designed to keep our pipe at as low of a normal level of operation as possible, right? We want the throughput of our network generally to be wide open, right? So if we think about the throughput of our switchgear, if we think about the capability of our cables, all that stuff, the meat of our network, we want to be ready to flood it, right? We want to flood it at any given moment so that stuff still gets through in a timely fashion. If this is our baseline operating level and then we try and push more through it, all the information is going to get there according to TCP/IP rules. It may just get there delayed. It may get there out of order and need to be labeled. The receiving device may miss packets and have to read it, which takes time. So we're going to make decisions to put together an entertainment control network that maybe if we were building a network for an office or a retail space or some other place that we would worry about. It's all about keeping our system at a trickle so that when that big push of data comes, there's room for the water to rise and all the information gets there and doesn't get stacked up, right? So one of the first things is how we choose our topologies. And this has a huge effect on how systems operate, right? So we learned earlier on star topology is the way to be. It's hip to the kids. It's what everybody's doing. So this ensures that there's one connection point for every device between every other device, right? There's no loops. If I were to connect those top two switches, that will introduce a loop in the system. And the way that we're going to turn off management in a little while, a loop is just going to keep circulating information, right? Switch 1 sees it, goes, oh, I need to forward it on to this guy, and forwards it on to switch 2, says, oh, I need to forward it on to this guy, who needs to forward it on to switch 3, who needs to forward it on to switch 1, and you get a loop. And after a while, your network just crawls, right? It falls to its knees. So loops are really, really bad. And in fact, one of the #1 troubleshooting things that we have people do is if their system is being laggy at some points but not at others, or some things are behaving, it sucks to do, but it's the best thing you can do for your system is unplug flash cables and introduce each device back into the system one at a time. Loops are easy to introduce and wreak havoc. So that's a big troubleshooting thing, is to really, really make loops. When we're designing a network system, either installed in the building or we're expanding on something, it's pretty common for spurs to occur, which is where I start chasing off, oh, well, my backstage switch needs to go to my front of house switch, which needs to go to my dimmer room switch, which needs to go up to my catwalk switch, which needs to go all over the place. And we call these spurs because they're not really centralized. There's a path that they're going off of, right? There's no loop, but there's a long line of switches. And the problem that we have to think about with this is a thing called network width, right? And that's to say, what is the number of hops from the two furthest away nodes that are going to be communicating with each other, right? Maybe my console and my last gateway, or my racks, or whatever. As we talk about, a switch, even unmanaged, still needs to take the packet that it receives, read who the destination is, and forward it on to the appropriate location to get it to the right destination. And that reading introduces a little bit of time, right? So by the time you start to introduce 8 to 10 hops, you start to introduce enough lag that you might start to see it, right? So you've got enough traffic on your network and enough things pushing through. As you go above 8 or 10 hops, you start to see noticeable lag. And it really matters when you're like hitting a blackout as your account, right? You hit blackout and your front house goes dark faster than your stage does, or your downstage goes faster than your psych because your psych is run through the basement and up over the river and through the woods. So you've just got to be cautious when laying out a network about the number of hops, because we're introducing delay. Other things which I haven't into a whole lot of, but something for you to read the technical specifications of your switch, is the throughput capability of your switch. That also introduce delays, because again, the information that's coming is going to be directed as quickly as the switch can deal with it, and a lower throughput will stack up and queue up before it can forward it on to the next point. So be really cautious about switches specifically at points of high juncture, right? One of the ways that we avoid any of this stuff is called a centralized star topology, right? So you'll notice here, instead of adding spurs to get all the additional switches, everything comes back to a centralized location, right? And when we're in this arrangement, we call all of the switches around the outside of our system an edge switch. Those can be configured very specifically, but in an entertainment network, they don't have to. And the centralized switch is called the core switch. And the core switch, again, can be a special piece of hardware, but it doesn't have to be, right? It can be copper. In some installations, we're using fiber to go to those links. I'll talk about fiber in just a little bit. So what's good about a centralized star topology is if it's set up right, there's never more than 4 hops in every single place, right? You hop to your first edge switch, you hop to your core switch, you hop to your edge switch and back out to your node. So at no point are there any 4 segments or 3 devices that are dealing with that packet, right? So more and more, as more things hop onto the network, centralized star topology is really the recommended practice, right? One of the other things is pretty common and gets discussed a lot is a ring topology. A ring topology breaks introducing loops into your network in that all of your switches connected, but 2 switches are configured very specially. And you'll see them near the top of my screen, they're linked with a green line. Those 2 switches have that green link, but that link is currently disabled, right? It's not passing network traffic. It is not part of the flow of data. So what those switches are doing is they are in constant communication with each other around the long path and are making sure that the ring is healthy and that they can see each other. So in addition to all the network traffic that they're passing, they're just checking in on their buddy, making sure that the path that's designed is expected to be there. And in the course of something failing, like a segment being severed or a switch going down or something, those 2 switches say, oh, we can't see each other through the ring. There must be a problem. We're going to heal that link that was previously green and pass information around the other way, right? So if a link is severed, then all switches come back online. If a switch dies, only the nodes that are connected to that switch die. So this can be a really good function separately because it's an auto-healing system. Some of the difficulties with ring topologies is that, again, you need a lot of knowledge to set this up. But depending on your site complexity and where your switches are located, it can also be really difficult to quickly understand what's happening with the system, how it's broken and why, right? If we have a ring topology and our stage left switch dies, we don't necessarily know where the break is, right? Did the switch die? Is there a power issue? Are any of those segments dead? Is the system feeding that segment dead or a port? You know, for businesses, for banking, this kind of auto-healing work because someone's going to come in and kind of figure it out after they get an error message. If we're trying to fix something like this over intermission, it becomes really difficult to deal with ring topology. That's just something to keep in mind. You also have to know what you're doing in deploying the ring topology, make sure that it doesn't interfere with any of the calls you're dealing with. And finally, ring topologies have the same concern of network width, right? By introducing more stops on a ring, you're introducing a larger network width and you're causing more hops. So you might have noticeable delay in components that are seemingly next to each other, right? If your bridge is over the stage and that first switch is stage left and that second switch is stage right and it goes all the way through the building to get to each other, you might have a delay in that system. So just be cautious about that. For now, you'll get different opinions based on different applications. I design a lot of systems for various size spaces. I still recommend centralized topology. I think that locating that core switch in a place like a booth or a dinner room where there's an expectation of knowledgeable people being located will give you a better indication as to what has failed at a central location before you go out in the field and try and find stuff. So that's that. A planned sidebar that might answer questions. Fixtures that take Ethernet directly. This is different than fixtures that have RJ45 connectors and take DMX over category cable, right? We talked about that a little bit earlier. DMX over category cable is, and it will continue to daisy chain. And DMX is designed to make 32 fixtures without any data degradation, right? It's designed to make those hops. It's designed to go 1,600 feet, and it can do it without any noticeable lag. Based on what we've been talking about topology, if you're using a true TCP/IP network port in a fixture, you have a switch in that device, right? At least a port switch. One that takes the data in, one that passes the data to the next fixture, and one that passes the data to the actual electronics of the unit. So your two options are you can either daisy chain, which we talked about. As soon as you get past that 8th or 9th fixture, you're going to start seeing lag. So if you snap all those fixtures to red, you will watch those changes cascade across that pipe. It is the nature of TCP/IP networking, and it's the best that we can do. And I got to say, you know, I'm skeptical. You know, some of the best switches like Cisco and things like that have really high throughput. Is the manufacturer of your moving light buying a switch that has a high enough throughput to manage passing that data as fast as possible? I'm going to suspect probably not. So just be careful with this stuff. If you're going to try and use fixtures over Ether, another way to do it is to put a switch at a central location, like on the end of a pipe, and home run. The disadvantage is you're using a lot more cable, but now you've only got one hop between the fixture and the switch at the end of the pipe, right? So if that switch is going back to a central core, you're back to your only 4-hop situation, which is not a bad thing. Great for permanent installations, maybe more difficult for shows that are changing over, right? So just decide what you need. You know, DMX is still really great. Like I said, we call it the last mile protocol. What we like to do is put network in every location that we can get it, knowing that we can break it out to whatever we want it to be that day. So I can slap a gateway on, and now I've got 2 or 4 universes or whatever that allow me to go up to 1,600 feet and up to 32 devices from that location. So don't be afraid of DMX. Don't think that DMX is going out of favor. I think DMX is still going to be around for a while because we're borrowing network technology. Unless there's major innovations in how some of this gear transfers stuff, we probably won't see huge adoption. The other thing to remember is that switches have to be powered to pass data. So in my top example, if fixture 3 dies and loses power, everything downstream no longer receives data. Whereas DMX can passively power data even if the fixture is powered. So again, don't be afraid of DMX. Use your network as your big pipe to get all of your information everywhere on the space. And then in your last mile where your fixtures are, come down to DMX and daisy chain it and use it what it's been good for the past 30 years. Cool. The other sidebar is fiber myth. I'm always hesitant to talk about this, but I think there's a general misconception that if you add fiber to your system, that it's instantly going to be faster, and you've got to use fiber in order for the system to work. That is a misconception. Fiber, a lot of fibers have equal potential to category cable as to how much throughput they can have. Fiber has more potential, but you're always going to be limited by electronics that are plugged into either end of your fiber. How much throughput and what bandwidth is your switch going to be able to generate, and is the other side going to be able to receive? So by the nature of just having fiber, you're not suddenly getting a faster network. Your switch here is what's going to determine how fast your network is. So just be aware of that. I think that there's a lot of good uses for fiber. Again, the 2 things that I really use fiber for very often is to get over the distance limitation of copper. copper stops at 100 meters. So if I'm going through a large performing arts facility and I need my conduit to run up over the catwalks and down through the basement and around the back and through the parking lot and then back to my backstage rack, I'm going to use a fiber link so that I can get over that 300-foot limit. And that's a really, really useful get out of jail free card to handle distances. The other thing is kind of going back to that centralized core topology, right, that core store. I'm using fiber between all of those links to the core in modern systems that I'm designing, not because I am expecting higher speed, but I like to differentiate those connectors from my standard copper connectors, right? If they're installing wires in the wall, I want the people that are operating the system for the next 30 years to understand that the links between their switches are different and are special from the link between their switch and the port in the wall, right? So it's a little bit of a design intent. It doesn't actually change the functionality of the system, but it allows a different connector type to be understood that that's a different purpose in the system. So consider that if you're laying out systems. It helps differentiate the intent of that line as a trunk line as opposed to an end of an edge line, right? Also, if you're pulling fiber, a lot of sort of the latest and greatest fiber does have a lot more potential. So if you're putting it into walls, maybe go with a fiber that has a higher potential of throughput, knowing that in 10 years when the system needs to be renovated, you can put on new switch gear and the system can handle that, right? So, so just make systems that are smart about fiber. Don't think it's a magic cure-all that will get you speeds, right? Before I go into, I have switches to cover, I have DHCP to cover, and I have Wi-Fi deployment to cover. So I'll probably go another 30 to 35 minutes if that's okay with everybody. Sam, do we have any questions that are relevant right now?
Yeah, two questions came up, both tangentially related. The first is, what's the easiest way to build redundancy into a star topology? And then the second, on the redundancy idea, is ETC looking at redundancy nodes, that is DMX with ring topology that auto-senses failure and auto-switches to backup?
I'll answer the last one first. We're always looking at where this stuff is going, and we're always looking at things that solve solutions specifically for entertainment. So yeah, we're kicking some stuff around. That's all I can say without violating my NDA. So you know, we're looking at the evolution of where do networks go next. You know, we're sort of at a big precipice where networks have evolved to a point where we want to reevaluate how we put systems together as a whole and what product offerings support that. We're also getting a lot more comfortable from a system design standpoint, again, of like, what is your core versus what is your edge, where redundancy is needed, things like that. And to sort of answer the first one, there are ways that you can set up a networking switches. The easiest is to have backup dry lines, right? So if a line fails, you can have another line that is run that allows you to plug in and go. Some switches can be configured to do that, again, sort of auto switching. That requires management and setup on your part. So that's something you would have to do. It's not something that ETC currently recommends for standard systems because a lot of users don't know how to fix it if it breaks. So we always try to recommend systems that are going to work, you know, all the time, bulletproof, with the least amount of management and maintenance. So things like redundancies that are automatically built into networks right now require configuration and management at switch level. That being said, ETC is always working on an exciting product. So we're thinking about ways that we can help with that. Did that kind of answer those?
I think so. And just one last thing while we're still on topology, just I think that is worth restating. Someone asked how many switches you can connect to a centralized switch in a centralized star topology. And so I think just looping back around, literally, figuratively, all the like, about the relationship between switches and that topology.
Yeah, if you're in a centralized star topology, you can connect the quantity of that switch to other switches, right? So if your core switch is 48 ports, go to town connecting 48 other switches with it. You'll need to be careful about your throughput, right? Can that 48 port switch handle the amount of traffic that's going to be generated by the amount of devices that are connected? If I'm going out to a switch that has maybe one or two devices connected to it, and that's true throughout my topology, that's probably fine. If I'm thinking about going a 48 port to 48 ports, now starting to look into wanting to hop on a managed network and figure out a way to shape that stuff so it works better. Again, for entertainment networks, generally we're looking at probably no more than 50 devices on a network, right? If you've got a controller, if you've got a backup, if you've got 40 gateways and some other devices, right now that's all most people are kind of getting into. So if you're laying out a system to be put into a building or temporary to tour or whatever, you know, you got to first start with what you're trying to control. What actually are you going to plug into it? There's no reason to go, you know, totally crazy and do 500 different things into a single switch because you can. Look at what you're trying to do. It may be that the right way is just a simple star topology and 48 devices come directly into that switch and that's all you need because that's all you have. So just be smart about that stuff. Yeah.
That's it for now.
Should we talk about switches? Switches. So this is going to be a little vague because there are just under 1 billion new switches that come out every day. I feel like they're like LED lights, right? There's just 100,000 of them. But some of the big questions is what I'm going to try and hit, make some basic decisions. And one of the biggest questions that you get is unmanaged versus managed switches, right? We recommend and we prefer on a standalone lighting control network an unmanaged switch, right? All an unmanaged switch is doing is taking the information in, reading who it's supposed to go to, and sending it to that other device, right? It handles MAC addresses and multicast lists, and that's it, right? It's basic. It is as plug and play as you can get, and that's what we want. For most of our systems, we don't want to think about going under the hood on a per production, per configuration basis and tweaking all stuff so that stuff talks. I've got a job, I've got a life. I don't want to plug in my cable and make it work, right? So ideally, you'll find unmanaged switches. And most managed switches at a certain tier of the market can have all of their management turned off. So you can have a managed switch that has all of its management turned off and is just behaving the same way as an unmanaged switch. And we'll talk about that when we talk about quality of switches in managed switches. Again, the biggest hurdle to these is setup is required, right? You need to be able to understand and configure the switch to allow critical network traffic for lighting protocols. I mentioned earlier that a lot of our systems, by default, their protocols are looked at as spam by standard switches. You got to be able to turn all that off and understand it. If you do have that level of expertise, if you do understand stuff, you have a lot of advanced things that you can do, like monitoring of traffic, shading your traffic, setting up VLANs, which are very useful. There's tons of things that you can deploy that the real business and internet world uses. If you call phone support and your system isn't working, the first thing they're going to do is tell you to turn all that stuff off. So be really careful. Don't you know more than you know. This is the heart of your system. It has to work, and it has to work all the time. be really, really careful what you put in. We recommend unmanaged, stupid, wide open switches. And it's because they're really easy to troubleshoot, right? So keep that in mind when you're looking at managed versus unmanaged. This graphic is a little dated, but we want our network to be as flat as possible, right? We call a fully unmanaged network a flat network. There's nothing happening, nothing of the information being messed with. It's just coming into the switch, being passed to the next destination, right? So flat is what we want. Take management out of the way. Cool. Power over Ethernet is a feature that some switches have, right? It's an additional protocol. This isn't a requirement, but it's a really nice convenience. So power over Ethernet, these cable pairs on the category cable that aren't being used to send data, and it sends voltage to power small electronics. Portable switches are really good for convenience, and this is actually a switch that I use in New York and that Sam stocks for us. There's 4-port PoE. You can kind of see that small ring around the ports. That gives me some PoE and some standard. It's really for like tables, troubleshooting in a shop, stuff out on a small site. I can throw that in my backpack. I can plug my laptop into a non-PoE port, my gateway into a PoE port, away I go, right? And now my electronics that can be powered by PoE, I don't have to travel with them. I've got this little switch and it's good to go. Some of these switches also have an SFP port, so if you want a fiber link in, that's a possibility. I know we use Cisco 350 series switches at ETC. They have some fixtures that can do that. Some switches that can do that. Portable switches are great. We want them unmanaged and stupid. We just want to plug in our stuff and get going. For switches, you probably, if you're going to be utilizing PoE, you want every port to have PoE capabilities, right? You want to be able to plug in a PoE device in any port in your space and be assured that it will work. So there are 2 things that you need to look out for when you're looking up a switch and reading its specifications. There is the power budget for each port. So what is the wattage that I expect to drive off of a PoE port? Can the port handle that? Is it watts? Is it 5 watts? Is it whatever, right? So look at the gear that you're going to be plugging into your system and see what the capability of the switch is. My experience, there's not a whole lot of entertainment gear that is even getting close to the level of what modern PoE is providing. Modern PoE is starting to provide power for lighting, right? We're starting to see PoE switches power downlights in lobbies. So we're kind of under the threshold of that, but double check. The other thing that is a gotcha is you need to check the power budget for the full switch. Many switches say that they can do 90 watts per port, but the entire power budget for the switch is only 1,000 watts. So only 12 devices can plug in to that switch, and then you're out of PoE. So the best switches have full rated budget PoE for every port. Figure out what you're going to need, but don't be surprised. And ones with PoE cost more money, right? Like, you got to weigh what you're going to do, and you're probably going to invest more. But for an install switch, that may be worth the investment, right? Also consider that more power coming through a PoE switch equals more fan noise, right? The more power that's going through the ports, the more heat that's being generated, the more fans will be included in the switch to keep it cool. If you're going to be putting these in quiet places, they make switches that are fewer ports, like an 8-port, that is all convection cooled, but is full PoE. So if you need a switch backstage or a booth where your operators or stage managers sitting, look at options that are fanless. You'll have less ports, but you won't get the noise of the fan constantly driving, right? So be aware that that's a thing. And again, I think things that are being installed in your building are worth the money. Like, I don't know, Sam will tell you, but I think this is like a $50 or $60 switch. If it breaks, if one of the ports stops working, I can send it back to be recycled, and it doesn't matter. I'll buy a new one. I expect this switch to last 8 to 10 years in my installation, and I expect it to be proof every single day. This is where you spend your money, right? So when you're looking at brands, remember that switches are the absolute heart of your network, and switches in a lot of ways are still a you get what you pay for situation, right? So we talked very early on in the call about consumer level, prosumer, and professional grade. You'll want to be looking at prosumer up to professional grade, depending on where they are in your system, right? If I'm doing a core and edge switches, I'm going to try and get professional level switches like Cisco, which are for small office, the 350 series. There are systems that are, you can get a switch for $40. You can get a switch for $30,000 for data center cores. What your budget is, but a $1,200 to $1,500 professional grade switch is not that expensive. So just be aware. And you plan on getting on a replacement cycle, right? Let's say you have 8 switches in your system, in your space. Maybe once a year you're budgeting to replace them. What you don't want to get to is in a situation where in 10 years, switches are starting to fail and you need to replace all of them. That's a big cost. That's all up front. A lot of times you say, let's spend $2,000 a year on switches, patch cables, and maintenance, and just keep that in the budget so that you're not surprised if your system goes over. The other thing that you can do, I like when I'm putting together systems, is to try and have all the same switches with all the same configurations throughout the whole system. And what does this give me? Again, I could do, there are switches, somebody asked a question earlier, there's switches that do full switching backover, right? You're running 2 redundant tracking backup switches, just like you're running consoles. And if one fails, the other automatically takes over and you're running. That is also a $30,000 core and $12,000 the edge. Are you willing to spend that money for your entertainment system? Or do you want to spend $1,000 where if a switch fails, you have a spare on the shelf that's configured, you slap it in, you replug it, and you're up and going in 15 minutes. For most spaces, that kind of downtime is acceptable. If you're running a theme park, commercial theater, a show in Vegas, if you have to shut down a show, it costs a lot of money. Maybe you're willing to invest in higher level auto redundant systems. They exist. A lot of the redundancy in theater and in entertainment have mostly to do with budget, right? So shop around, see what you need, and understand when losing a show is good enough. Things like a spare switch, things like keeping all your switches to the same configuration so you reduce the amount of change over time are really good ways to make sure you're back up and running for a reasonable price. Yeah, I'm happy to talk about ideas on that stuff maybe a little bit later because I don't want to keep you guys too long. I'm going to plow through when we're designing entertainment control systems, do we use static or DHCP? And again, I'm going to get through wireless deployment and then we should be mostly done. So thanks for holding on. Sorry this went long. I hope it's been useful. And we'll get to some of your questions in a little bit. Static or DHCP. So for an entertainment control network, like we talked about, static deployments are really predictable. We like that when we're interacting with show control devices, P strings or whatever, but they require a lot of human management. The network grows, changes, and moves around. On the other side of the coin, DHCP deployments are automatic and just happen the way you want them, but there's not a lot of consistency for troubleshooting. You can't just ping an address to see if it's on. Your processor addresses, so your show control is broken. So what do we choose, right? Which one are we going to do for our entertainment control system? It's an oldie but a goodie. Why not? Yay! What's great about the way that IPv4 is set up is that if you set a device to have a static IP, it's going to retain static IP even if there's a DHCP in the system. The way that works is once you set a static IP, will not request an address from the DHCP server, right? So you need to consider what things you want on each side of the line. Some things that are good for static IP addresses, consoles that link with other systems, right? I want those to always have the same IP so my sound system or QLab or whatever can interact with it. Dimmer racks are good for static IPs because they're literally bolted into your building. They're not going anywhere. If your dimmer racks are moving around, you may have a bigger problem figuring out what your IP addresses are, right? And what are some other things that are coming on and off your network? You know, maybe you have gateways, rental gear off that you don't want to think about it. It's going to be here for this production. It's going to be here for this tour stop. You just want to put it on at work and move on. Remotes, guest designers, guest programmers, right? We need to get a remote system. That's a great place for a DHCP. So not all devices have to subscribe to one or the other. Make smart choices about which things get static IPs, and then let other devices request a DHCP. Deployment of DHCP is important that you only have one DHCP on the system at a time. And this is because each DHCP server retains a table of what addresses are used, unused. And what you can get is some conflict, right? So if I pop in and decide that I have a DHCP, and for whatever reason, my phone sees DHCP server 1 first that day, it's closer, DHCP 2 is off, whatever. DHCP 1 is going to see 85.102 is the first available, give it to my phone, and away we go. And we're happy to be on the network, it's great. But now, your phone comes into the network, and it sees DHCP 2. Well, now, because those tables aren't synchronized between the two servers, you're going to get the same IP address that I got, and we now have an IP conflict. And as I mentioned, IP conflicts will sometimes lock switches, lock out ports, and things won't be able to reconnect until the system is restarted. So be really, really careful about DHCPs. The trouble that I see people run into the most is that in the world of ETC, consoles can be DHCP servers, paradigm and conductor processors can be DHCP servers, RPUs and RVIs and pucks can be DHCP servers. If you have a convert session or a Wireshark session online, those can have DHCPs turned on. So using a tool like Wireshark to see which DHCPs are present and go through and turn them off and pick just one is going to be really important if you expect to deploy it successfully, right? We can't have multiple DHCPs on the network. It will cause problems in the long run. So if you're going to use it, figure that out ahead of time. You can also, all the devices will have ways to clear that table if you need to reset it, because again, ETC devices, our lease for our tables is 10 years. So you might want to reset it if you're redeploying. Okay. A quick little overview of deploying wireless networking for an entertainment control system. This is prescriptive. These are things for you to think about. There's a lot of options and choices in deploying wireless networking. And so I'm going to give you some questions to ask as you're looking to deploy it, but there's a lot of resources to help you and people to answer questions based on your specific needs. But the big thing is to remember that wireless DMX, wireless networking is for convenience, right? We'll talk about that in a second. First of all, there are wireless routers and there are access points, right? What are the difference? Wireless routers are generally consumer-grade devices, and as their name implies, they have a router. We'll look at that in a second. A wireless access point is a device that takes the copper and translates it to Wi-Fi, right? So wireless devices end up being on the same local area network as all of your other devices, and that's great. We're just converting copper into wireless, and you set, if there's a DHCP server, it serves all that information over the other side. If you bring a static IP address, it's there. So, there's real advantages using a wireless access point because it's easy, right? It doesn't require It's not blocking any of our traffic. But again, professional grade switchgear, wireless access points are often more costly, right? So it's not uncommon for, this is a Cisco, we use Arrow at ATC. This is like a $500 device, but it's really robust. It has a lot of capability if you want to manage it, but at the end of the day, you can all and just allow it to be a wireless access point. Routers, on the other hand, just as the name implies, have a router built into them. And sometimes that router exists between the wide area network, or what you plug your internet into, and the internal switches. Oftentimes, your wireless is a part of the local area network, as your local ports on it. But the key thing is that these are really designed for consumer-grade activities. Again, gaming, internet surfing, streaming. And so a lot of the settings that they have are settings that will set a bunch of different things in the configuration that are good for streaming, per se, but may block certain things that lighting networks want. So you can get a wireless access point, or excuse me, a wireless router for 30 or 40 bucks, and they're nice and cheap, but they may be inconsistent and they may block, right? So be very, very cautious. Even if you can go in and turn on and off some of the settings, that router may be blocking things that we as lighting protocols need for proper traffic transmission. So just be really, really careful. And the unfortunate part about these is the documentation, unlike pro level switches, doesn't tell you what a lot of those on-off buttons are actually changing in the manual like that. So it's a little unclear sometimes with what wireless routers do. So maybe you're using this for portable or for convenience. You can find one that works really well for you. For install, I'm always recommending wireless access points. You'll also want to do a wireless deployment survey, right? As some of you have taken some of the classes on our learning stage have seen, there's a lot of interference out there, right? There's 1,000 different Wi-Fi access points like at my house. So we need to try and move our stuff and understand the interference, right? And try and find channels and bands that have little interference. There's some free tools that allow you to look through that kind of stuff. Things like Insider, INSSIDER, allows you to scope whatever your laptop's radio is capable of seeing. There's other tools like Wi-Spy, which are actually a radio dongle that allow you to actually see the spectrum that's there. If you're doing professional wireless deployments, you might look at more expensive, scanners that don't just show you Wi-Fi access points, but also show you deployments. Things like satellite trucks, microwave, tons of things that interfere in this bandwidth. So we just have to be really cautious, and we need to understand that these deployments are for convenience. And I'll touch on that again in a second. Wireless security is important. Keep it locked down. We don't want extra traffic, right? What I've been preaching is that we want a thin layer of traffic so that we can let the system contract. So keep it locked down. One of the easiest things to do is to hide the SSID, right? The name of the network. You'll see it automatically. Use security passwords. Don't just call it EOS or lighting. The amount of networks that I've been able to crack into because it's something obvious. Take it seriously. You want to keep people off this network. Change your password often if you have people coming in and out. It's just as network secure as anything else. And then I think the ultimate level of security is, does a router need to be on, right? If I've got a wireless router and the house is open, why do I need to have wireless on? I'm not going to be doing any channel checks. I'm not going to be doing any notes. Turn off the physical device, and that is the safest way to keep Wi-Fi from causing you issues, right? So that's my recommendation. Again, it's for convenience. When we're doing little things like remotes, like bringing up channels or quickly running through some queues to check out some lights, this is great. These really thin conversations that the devices are having. It's not a lot of bandwidth. So these are the sorts of things that are designed to go over Wi-Fi. It's easy, and honestly, if you run into network traffic or if the Wi-Fi fails, you can do everything you need to do from a console device or hardwired into the network somewhere. You don't need to worry that this is show critical, right? If you're running your queues off of your IRFR for a show, it's going to bite you at some time. So be really careful. This is for convenience only. Again, things that are heavier duty, like streaming data to devices, like multi-console communication over Wi-Fi, like setting up a client over Wi-Fi, those require so much more communication and bandwidth that if you get interference, you're going to lose connection. And ETC's official stance is these things are not designed to go over Wi-Fi. So if I take my Nomad and I try and put it over Wi-Fi to my console and it keeps disconnecting, you're going to call phone support and they're going to say, yep, you're not supposed to put it over Wi-Fi because that system is not designed to do that. It's designed to go over copper. So just be aware that all those sorts of things are not recommended. That's all Wi-Fi deployment, right? TCP IP over wireless. Things like wireless DMX, you're good to go. These are dedicated radio deployments. You still need to do a site survey to determine what radio channels you want, and you still need to deploy the radio according to the manufacturer's recommendations, like antenna position, devices, line of sight, things like that. So just be aware that things have to be deployed appropriately. The last kind of section that I get a lot of questions on that I'll answer is what about the internet? And what about the internet on an entertainment control network? What about the internet? This is a band. This was meant as a joke. They're awesome. Go check them out. We're talking about the internet and not wanting the internet on a lighting system. We're really talking about the fact that internet activities and internet signals will crowd up our bandwidth, right? As things are discovering each other and looking for each other, we're filling that pipe where we don't need to, right? We should have a separate network for internet for production people or whatever. There's no need to have our control network right now connected directly to the internet. It's less about viruses, right? A lot of our stuff is specialty built. A lot of our stuff doesn't run operating systems, right? Gateways, those are sorts of devices that run operating systems. So they're very unlikely to be infected with viruses that infect. Even consoles use embedded OSs, so they're more unlikely than your computer to get infected. It has happened, but the effects are minimal. But we're really, really concerned about our network being able to push data through at a moment's notice more than we are about the risk of viruses taking down our system. There are specialty devices. Sometimes we do need to connect to the internet. And this is a router, right? This is a purpose entertainment router that allows us to send certain things from the entertainment network through to the internet and vice versa. ETC makes a box called Conductor. It has some very specific features. Go look at it. It's not a remote control my device through the internet. There are some products that are offering that sort of access. So look at them, see what you need. Right now, though, this is really purpose-built. So if you have questions about that, answer. But our recommendation is to still keep that network separate by itself, no internet, just lighting, or whatever else you're building it for. So that's the big presentation. Wow, we're only 45 minutes over. Why don't we chew through some questions?
A new record, Nick. You did such a great job.
Oh, well, thanks. A new record for going over or staying under?
I'm going to let you decide which way that record works.
Perfect. So, can we answer?
All right, couple questions here. So this one has been sitting here for a little bit. Kind of going back to Ethernet in whole systems. So in a venue where you have a switch in the booth that is running to Ethernet outlets on your stage, do you need to be concerned about interference on the unused outlets. So outlets that are not powering a device or anything, could those be creating interference on a system?
It is unlikely. It is, if there's nothing plugged into that port, even if it's plugged into the port on the switch, there's no communication happening, right? So that abandoned port, we'll call it, won't have any electrical signal going. If you're getting interference or you're concerned about interference on your line, networking cable should be run away from high voltage circuits, right? As you start to run parallel with high voltage circuits, you can start to get electromagnetic interference in lower voltage signal lines. The recommended practice for all networks is to intersect high voltage at a 90-degree. The conduit has to pass over each other, that they do that. Other things to check for, if you can trace the line, ideally those lines would be run in their own conduit to that box so that they're completely shielded from everything else. It is unfortunate, but I have seen it where people have spliced the line in the middle, right? Networking that you can't, line has to be fully intact from point A to point B. If there's a space in the middle, they compromise the data signal. So I've seen contractors that have wire nutted two pieces of Cat5 together. So looking for things like that in line. You can buy or rent networking tools that you can plug into one side of the port and plug into the other side of the port, and it will tell you the distance that wire is. It will check the lines for errors or for inconsistency in the electrical signal. Those are good things to do. And then sort of a step that you could do is, if you're concerned about a lot of lines, you can hire someone to come and do what's called certify your network, which they go through, and every line gets a checkup. It's tested out, and every line has a report on it. And that's a checkup for your wires in the wall, less and less about your port, your switch gear and portable gear and things like that. So I would start looking at those things, but a dry line shouldn't be causing interference because there's nothing running on it.
I had a comment on PoE from Vladimir. He says power can share pairs with data in certain circumstances, ergo 1000 base T, when there are no spare pairs. Modern PoE IEEE 8023BT up to 71 watts per port does utilize all 4 pairs of Cat5.
Yes, that is all correct. Yep. Thank you, Vlad.
Let's see. From a while back, do you know of good brand-free application for monitoring the different network protocols? I don't know. I doubt that there is an all-in-one for all the different network protocols, but obviously we do SACN on board with all the EOS stuff, and we had some ArtNet resources shared. I don't know if there's anything else you think people should be aware of.
Yeah. The best thing for streaming ACN is Streaming ACN Viewer, which is a side project by an ETC employee, Tom Barthel here, and a few other people that are at ETC. It's a separate project that is able to be on Mac and PC. It's a piece of software that allows you to monitor different universes of ACN on the network. It allows you to generate ACN so you can test stuff, and it's free. So that's a really, really good tool for ACN. And I know a couple of sites that actually have computers that are on the entertainment network exclusively that keep that software open just to sort of keep an eye on the health. It's got finding tools and things like that. Honestly, the catch-all is Wireshark. Wireshark is also free, but it's really complex. It can sniff almost anything on the line. It can do line captures if it turns out that problem. But it is a IT professional's tool. So there's a bit of a learning curve to it. They have some pretty decent documentation. But if you're looking for things like DHCPs, if you're looking for time servers, it's not just entertainment protocols, it's also networking in general. As Matt Pumplin, who's one of our service engineers, said, working in Wireshark isn't like looking for a needle in a haystack. It's a bit like looking for a needle in a needle stack. So you kind of have to know a bit what you're doing in order to find some stuff. But that's the end all be all tool is Wireshark. And if when we try and diagnose problems for sites that are having really severe kind of bizarre issues that we can't find, we'll throw a Wireshark capture online and start to get some of their information. I think, and Abby might be able to correct me, that some of our service techs will also use Wireshark when they're installing a system to do some of that diagnosis that we were talking about a few minutes ago. So what else?
I think this is a good point that I don't believe we touched on. What setup would you recommend for allowing guest remote access to a lighting system? If all your devices are static IP, but you want to run DHCP over a WAP for remote access for guest designers, anything to know about avoiding conflicts?
My personal preference is I would recommend a wireless access point over a router, right? Again, the idea that you're just extending the copper realm into Wi-Fi realm. Obviously security, hide your SSID, set a password, and make a device on the control network be the DHCP server. A lot of wireless access points can set their own DHCP server for just the wireless side of stuff. While that can be convenient, that can also be hard to manage. So sort of depending on your prowess, having it as one thing on your physical network that extends to your Wi-Fi is a lot more useful. And that way all the guest designer has to do is connect to the Wi-Fi using the credentials you gave them. The copper through the wireless access point will give them the DHCP services they need, and they'll be there. I also recommend any DHCP server will allow you to define which addresses it will dole out. I recommend putting those in a range that you know and recognize. When I architect a network, for me, it's 10.101.85 and 10.101.86 are my DHCP addresses. Why? Because I can hop on and see something with that address and know that I didn't give it an address. It was automatically there. So if it's causing problems, I can kick it out. I can go address it. As a network administrator, it makes it a little bit easy to know where that stuff is coming from. And you'll come up with your network schemes in general. Like I said, we use them for organization. .90.x are my console devices. .50.x are my DMX gateways. .85 and .86 are my DHCP. So figure out a system that works for you. But I think allowing the DHCP to be on the physical copper and allowing the physical copper to extend to Wi-Fi via a wireless access point is a lot less configuration than trying to have the wireless router deal with its own DHCP on just Wi-Fi. That's my experience.
Next question, and then I think I have a good closing question that someone is asking if there are other online resources you'd recommend, but I think first I have one or two more nitty-gritty questions, and then I think we'll wrap up. Does that sound good? Okay. So Matthew is asking, does IGMP snooping being on cause problems with SACN? They were running into issues on motion pictures with universes not being read by a gateway.
Yes. We definitely used to have issues with that. I think that we have resolved all that, and I think we are now recommending that IGMP snooping is fine. And I don't remember all the details off of that on the top of my head. I would say check and see if there's a support article for it on our website. And if you can't find anything that gets you the detail that you want, let me know, and I can get you some resources.
The next question, is there a preferred configuration, primary, secondary ports on multi-port consoles? Does one have a higher hardware priority or faster processing?
It does not. They're both equal. There is a sort of default out of the factory, and I think that changed based on generation of hardware, but it doesn't matter. Both ports are equally capable, and both ports have a lot of options. So if you're looking in your network configuration in your shell on your EOS family console, you have the ability to turn on and off a lot of different protocols. You have the ability to change priorities and things like that. But generally, we don't prefer one over the other. They are numbered though, so just make sure you're plugging the correct one into the correct port, right, for what you're trying to do. The other thing that I'll say is that there's a thing that confuses people in there. When you're in your protocols area of your shell settings, whether ACN and Net2 and ArtNet are being broadcast on a particular port, there's another button in that area that's called default. And what default means is that when you patch something in EOS, it will automatically patch to that protocol. So if ACN is set to default, if ArtNet is set to default, if Net2 is set to default, and you patch a device, then it's going to take that device, patch them to all three of those, and it will output data to all of those protocols. A way to start reducing network traffic is if I have a huge video wall that's doing ArtNet, and I have a bunch of movers that are doing ACN, in patch, I can decide with my my interface box which interface that's going to output to, which protocol it's going to output to. So in that example, my huge video wall, I'd go into interface and only select ArtNet, and in my moving lights, I'd go to interface and only select ACN. You can, by default, turn off, if you're never using ArtNet, you can turn that off as a default patch option in your shell settings and network.
One last question, and then I think I just have a wrap up about this, the resources.
Right.
Someone is asking, they're using EOS with Hypnotizer, and on ArtNet it works fine, but with SACN they've had issues. Do you know if that's a known problem or they just might be a setup issue?
The only thing that I can think, I know, again, ArtNet has a couple of additional handshakes under the hood between certain manufacturers. So it may be that it may be that the Hypnotizer is coded to understand ArtNet better than ACN. I don't know off the top of my head any specific issues with that. If it's something that you keep running into, again, ArtNet and ACN can live together harmoniously. So there's no reason that you can't use ArtNet to control the Hypnotizer and use ACN to control other things like gateways. But if there's a reason that you need your Hypnotizer to receive ACN, I would first just double check that all the profile addresses line up to what the Hypnotizer is expecting to hear. And maybe contact them and see if they know any issues, and maybe get something like SACN stream, SACN viewer, and see if all of the levels are coming out of the console the way that you expect them to. I'm a little surprised that out of the same console, ArtNet is behaving differently than ACN, but check with the Hypnotizer folks and see if they have any thoughts on that. There may be some extra voodoo in the ArtNet that ACN isn't providing.
All right. Do you want to keep trucking along, or?
I think we've gone an hour over, so I think we should probably wrap it up. I will say a couple of resources. You know, and I can't. pull it down without toppling a lot of other books. John Huntington wrote a book called Show Networks and Control Systems that just came out in a new revision. And that is like the definitive industry standard for control networks, right? It covers a lot of other things that we didn't cover today. So it's light on some of the stuff we talked about. It's heavier on more of like the industry control protocols and things like that. But if you're looking for a single resource that's written by someone who is a top tier expert in our industry, John Huntington, Show Control Networks is it. I think it's on Amazon. It's a good book to have for resources. If you're looking to get more into, the kind of beauty about entertainment networks using TCP/IP is none of this is a secret, right? If you want to go down a rabbit hole, there are tons of resources for you to learn more about networking in general. Whenever I travel around to universities, I always recommend that students take a intro to networking class from their IT department, the people that are teaching IT professionals. An intro class to networking is going to get you so far deeper than what you actually need for a standard entertainment network, right? What they use to configure the real world stuff, we hardly touch. To that end, Cisco Networking Academy is a really, really great resource. They have free online stuff. They have stuff that you can pay for. You can get Cisco certified. It's probably the highest top tier resource, I think, on the network because it's coming from the people that make it. So I think that's a really, really good resource. ArtNet Nominator had been mentioned, as well as Wireshark and Streaming ACN Viewer. Those are all very, very good. Yeah, if there are specific questions, this feels like, regardless of how long all of us are stuck at home, it feels like maybe in several weeks, there's enough interest to do maybe a bit more of an advanced session, which could be fun. So I'll start maybe working on that for, a couple weeks from now. We've got some other topics we want to cover for you, but we could get into a bit deeper of that stuff. VLANs is something that a lot of people are interested in. We could get heavier into Wi-Fi deployment, things like that. But I'll say that also, we have a lot of really, really clever, intelligent people that work at ETC. So if you have questions, get a hold of us, right? You can always email me directly. Again, nick.gonsman@etcconnect.com. I will try to the best of my ability to get you a timely answer. Another great resource, if it's not timely, is service@etcconnect.com. They try and get to that as often as possible. If it's how-to stuff, I would say try and find resources on the internet. The service people are trying to support people with technical problems more than like, can you explain a DHCP to me? So try and be mindful of their time and other people's needs. But yeah, we want to be here to help. So don't hesitate to reach out. Again, in the times that we're in, it may take a little bit longer if it's not a mission critical moment to moment thing. But if it is, our phone support's still there. So give them a call if you're running into an issue and you're still doing production or something. I know we had a bunch of questions that maybe didn't get answered. So feel free to email me. Feel free to be in touch and with other things that come up later. And yeah, we'll post this on the website. I thank you so much for all your time. I thank you for sticking around a little bit later. We've got some more upcoming stuff on Monday and Tuesday and Thursday next week. So we'll be seeing a lot of each other.